Good morning, everyone, and welcome to day 2 of SeaGL 2021. We'd like to introduce our day, have a little bit of social stuff, and then get on to our keynotes. But first, I wanted to introduce myself a little bit. I have been volunteering for SeaGL for 4 years now and have been running the program with Nathan for 3 years. And I love SeaGL because it is the sort of crunchy side of open source. And that's not a view I don't think that you get many other places.
Yeah, and I'm Nathan Handler. As Rachel said, I've been co-chairing the SeaGL program committee and involved in the conference for a number of years with her. For me, SeaGL is all about the community. A number of our staff and organizers are coming together from literally all over the world to make this event happen. And it's all community run, managed by volunteers, and that's special to me. With that said, we wouldn't be able to put on this conference without a lot of generous support from our sponsors. We want to especially acknowledge our platinum sponsors, Amazon Web Services and JMP. Our gold sponsors, Schedules Direct, CSATs, Google, and the Ubuntu Community Fund. Our silver sponsors, Red Hat and Tidelift, and all of our community and press sponsors. We have a very packed schedule for today. We have plenty of talks taking place across 3 different tracks. You can participate and find these by going to attend.seagle.org there, or joining us on Matrix to interact and mingle with fellow attendees and speakers. We have an opening keynote this morning by Dr. Morgan Lemmer-Weber and Christine Lemmer-Weber, as well as a closing keynote to wrap up the conference later this evening by Cory Doctorow. We also have a number of amazing social events taking place throughout the day, and I'll let Monica explain those.
Hi, I'm Monica Madden, and I have been on the program committee with these two. And also, I wanted to tell you about all the awesome social events we have going on. First, we have a costume contest that will be happening right between the end of this and the beginning of the keynote in the social channel, and we will be announcing the winners of that at 2:30 Pacific time, and that will be immediately followed by Teagle at 2:45. So come bring some tea, fancy hats, optional but always welcome. Then we will be having a make tea sandwiches at 3:30 at 17:30. Sorry, I'm not able to do my time math. With Molly and Sri, and then we are going to be closing with our trivia contest for fun and prizes, and that is going to be happening at 18:30. We hope you can come to as many of those as possible. And for the costume contest, again, that will be happening in the social channel on Matrix. You can join the Jitsi conference there, and the voting for that will be going on for the next 4 hours. We will have a link to the voting form in the interstitials, so just share your screenshot either in the social channel, or you can email that to me at monica@seagle.org. Find me in the social channel afterwards. And so, Rachel, I would like to throw it back to you.
All right. Thank you so much, Monica. It is my great pleasure to announce our 2 keynotes this morning. We have Christine Lemmer-Weber and Dr. Morgan Lemmer-Weber. Dr. Morgan Lemmer-Weber is an art historian, avid crafter, and FOSS user and advocate. She recently completed her PhD in art history at the University of Wisconsin-Madison. A lifelong exploration of various handcrafts and media inspired her dissertation research on women in textile production in the Roman Empire. Morgan is also interested in the intersection of FOSS and academia, particularly in the context of digital humanities research. She built the original digitization of the William Ramsey ledger as a custom static site generator in Python. She looks forward to doing more digital humanities exploration and community engagement within the FOSS world now that her dissertation is complete. Congrats, Dr. Morgan Lemmer-Weber. Christine Lemmer-Weber is a longtime user freedom advocate. Her degree in interdisciplinary humanities with a focus on philosophy and ethics has informed her approach to free and open source software and free culture. She is mostly known for her work co-authoring and co-editing the ActivityPub distributed social network protocol. In previous times of her life, she worked as tech lead at Creative Commons, co-founded Media Goblin, started and ran the Liberated Pixel Cup, and kicked off work on CC by SA 4.0 and GPL compatibility. These days, her primary work is on Sprightly. Oh my gosh, I know Sprightly. It's such a cool project. A project to improve the security of federated social networks and bridge them with virtual worlds. When she isn't programming, she enjoys cooking, sketching, and making ASCII art. Thank you both. Please take it away.
All right. Are we live? Are we audible?
You are live. Thank you both so much. We're so excited to have you.
Thank you for having us.
Yes.
We briefly popped into the costume contest dressed as the sprightly mascots for Brucks and Goblins, but now we'll switch to keynote mode.
Yeah. We'll bring that back right at the end.
That sounds great. Hey, actually, we have a minute or two before we should really start our keynote. Can you tell us a little bit about your costumes this morning?
Sure.
We'll just vamp a little bit. This is going to be great. Everybody wants to see that.
Do you want to just really briefly describe Sprightly?
Well, Sprightly is, since we finished the ActivityPub Federated Social Network Standard, Sprightly has been kind of a research project for the Federated Social Web. And yeah, we have masks to kind of complete the character look. I'm not going to put it on so I don't get muffled. But basically
that's probably enough for a couple of minutes.
Yeah, okay, I should shut up.
Basically, there's a bunch of smaller projects within the larger project of Sprightly, and Christine drew small little sprites to represent each of the small projects
And
that
then
were
David Revoix.
Yeah, then the free culture artist David Revoix turned those into more developed designs. So I am dressed as Brucks, which is the pet name system within Sprightly.
And I am dressed as Goblin, well, the Goblin of Goblins, which is the distributed programming environment piece of Sprightly.
Amazing. You put my costume to shame.
Okay. Well, should we get going then?
Yeah. Let's do this. Thank you so much. Welcome all to SeaGL Day 2, 2021.
Cool. All right. I guess we have 2 more minutes. Should we just wait until that exact time? I guess we should go live. Okay. It seems like it's going live time. All right. As far as I can tell, it is currently time slot for us to go live with our keynote. So we will do that. Hi. I will take off this piece of my costume. I am Christine Lemmer-Weber, and this is Maureen Lemmer-Weber.
Hi.
And this presentation is
Interdisciplinarity and FOSS. So how can interdisciplinarity help your FOSS project and maybe your academic projects? So non-traditional backgrounds are and should be welcome just about everywhere. So in free and open source software, neither Christine or I had a standard computer science background when we got into this field.
Yep. In fact, so I consider myself an interdisciplinary humanities hacker. I'm kind of more known today for the work that I've done in terms of, more programming oriented things. So as in terms of technical standards like the ActivityPub Federated Social Network Standard, and as in terms of my current work on Sprightly, which is a kind of level up the decentralized social web research project that is becoming less research and research all the time. But I don't have a traditional computer science education. Actually, my major in college was called interdisciplinary humanities, which probably nearly no one has ever heard of before. Being a interdisciplinary humanities student, I was doing computer programming for fun on the side. And I bumped into the GNU project, and especially this GNU philosophy page, which really kind of captured my mind because I was studying a lot of philosophy, and okay, is this really, well, philosophy is everything, but in what way is this philosophy? So that got me really engaged in trying to figure out about the ideas of things. But I thought, I'm not really a computer programmer. I wanted to contribute in some sort of way to the free and open source software world. So I figured I would make a comic that was about a couple of nerds, and it's very dated, that are trying to figure out, that are trying to work on some projects and are having trouble getting them off the ground. But it would be kind of a way of advancing free and open source software by being this fun thing that kind of talks about it. That didn't go on for very long. It turns out that Emacs is a great gateway drug into the rest of the programming world. So by using that, somebody told me, well, you should just write your papers in LaTeX and Emacs. And I'm like, okay, I'll do that. And as I'm burning through coffee and burning the midnight oil, trying to write my papers desperately, I'm trying to figure out how to make things work. And it turns out that ended up being the opening of my programming career, basically, by trying to figure out how to use these tools that were meant for programmers as my my development environment. I became a developer. But I still didn't think that you could make money being a free and open source software developer. So I said, I'll just become a writer and an artist to pay for my programming. And it turns out that isn't how it ended up working. But, mostly I consider myself to be fairly self-taught or really book-taught, but even more so community-taught. And I think this is okay. But in many ways, it's all interdisciplinary. And see something that I think is fun and interdisciplinary, an animated ASCII art thing of a thing that Morgan and I made together of these two teacups that represent us and our own slogan, let's just be weird together. But let me turn to the other teacup.
So, hi, I am Dr. Morgan Lemmer-Weber. I am an art historian. I just received my PhD in May in art history, and I consider myself a digital humanities crafter. There's many sides to interdisciplinarity, and there's lots of skills that can be transferred elsewhere that you wouldn't necessarily think of to begin with. So this is the flip of the ASCII art animation that Christine just showed, and it's actually a little bit anachronistic in the slides because the needlepoint existed first, and then Christine made the ASCII art, and this is kind of our household slogan of let's just be weird together. So, obviously, art historians are common in FOSS activism, right? Right? Maybe not as much. However, I had an interesting introduction into coding. So I had been working for 2 years on a FileMaker database for an archaeological excavation at Sardis. And my spouse was a computer programmer and was willing to teach me how to program, and I was willing to learn. And that made me the most qualified person in my art history department to run a digital humanities project. And for those who don't know, digital humanities is basically just all of the same humanities research plus computers and digital elements that make it much easier to access that information. So for this project, which was the ledger of William Ramsey, who was a colonial merchant in Alexandria, Virginia, I built this website using Python and HTML and CSS and Flask, and I built a static site exporter. And I learned how to program the summer before this, and it was all peer taught because my very helpful spouse contributed to that. And then I built that entire thing in 1 academic year. Then, since my onboarding process to Python was a little bit difficult and I ran into some roadblocks, Christine and I decided to put together a series of workshops that were digital humanities workshops to teach programming to people who didn't think they could program. The unofficial subtitle for it was Programming for People with Imposter Syndrome. And we decided to use the programming language Racket because it has a picture language built in. So we could teach people the fundamental like terminology of programming, but instead of using math as a way to as the universal language that everybody knows, which side point is a difficult process for someone who is dyscalculic as I am. So we had our base tutorial being building snowmen by putting together circles.
So in general, what we're kind of talking about in this talk is that, interdisciplinarity, which means really we're also talking about how can you end up kind of doing, how can you end up combining different skills in different areas that you have, right? So in the Media Goblin project that I co-founded and co-ran back in the day, when I was lead maintainer of the project, one thing that we did and we tried to make fun was that we would have, I used my skills from having done artwork to be able to create this release art. And it's not really, you could say that it's not like really critical to the project to be able to do this, but it raised a lot of enthusiasm and energy. And I think one of the things that the Media Goblin project did well, maybe even more so than the code, was having a really interesting community. There's, if you have skills in other areas, it doesn't have to be graphical art. The Geeks project recently, one of their latest releases, they released a wonderful song made by Ricardo Wermus, and he has this wonderful blog post about how he made the song for their release song, right? So I think this is kind of interesting, the idea of, kind of celebrating milestones of your project by doing something fun and kind of artistic to go along with it.
So art history dissertation plus code. As I said, I'm an art historian, but I have this larger digital humanities background now. And after we did our digital humanities workshops, that included a tutorial on how to use Scribble, which is the markup language associated with Racket, to write papers. So I decided to dog food that concept and use Scribble to write my dissertation. Which here you can see the on the left, the source code for my dissertation, and on the right, the HTML output, because from my source code, I can output to HTML, to PDF, to LaTeX, and then Christine built a ODT exporter from Scribble as well, so I can export it and do the very last amount of formatting in LibreOffice. And then there are a lot of ways that my work is interdisciplinary that is not necessarily even related to the FOSS world. So for example, the sweater I am wearing right now is also my defense sweater, which is +20 defense against questions about women in textile production, because I knit it out of yarn that I got that was locally produced in Trier, which was one of my case study sites for my dissertation. And I wore this for my defense of my dissertation. So my background in crafting started before my background in academically studying craft production. And along those lines, I also incorporated experimental or experiential archaeology into my research. And this right here is the full-scale replica of a Roman upright two-beam loom, which does not exist archaeologically, so it's reconstructed based off of images. So for my dissertation, I also used a lot of programmer tools that I adjusted for the non-programmer. So I already talked about using Scribble as the environment and Dr. Racket as the environment that I was writing my dissertation in, but I also had things like version control, which honestly everyone should have version control for their dissertation instead of having 50 copies of a Word document that are just slightly different file names based on the date that they're done. So I used Git and also Git Annex because as an art history PhD, there are a lot of very large files. And then this all comes out into a physical book, which is the compiled output of my source code document in Scribble.
You could say this is literally the final step of the compiler from the source language of Scribble to the being a dissertation.
Well, you could say that, but obviously the dissertation, the defense copy is not the final copy of a dissertation. Hopefully it'll become a other book at some point.
Yes. So I think games are an interesting example for also of something that kind of combines the worlds of both code and artwork. To be able to build a game, you have to inherently explore the world of, bridging these two things together. This is actually artwork from Liberated Pixel Cup, which is a contest that we ran about 10 years ago that had both a creating artwork and creating games using that artwork component to it. Also, I think, I'm really grateful that I have a humanities background. So I actually, when writing the ActivityPub specification, I made the initial artwork mock-ups, then Emre, a volunteer, made this beautiful vectorized version of it. But, in addition to writing the actual kind of more dry specification text, I think one of the things about ActivityPub's success is that it comes with a tutorial that has a very narrative aspect to it that appears at the top of the document. So having, writing skills and artwork skills, those can appear in all sorts of other really important areas, such as documentation.
And then also there are transferable skills that are useful in just about any discipline. So I had a lot of experience organizing symposia and conferences and such in the academic world, usually for art history, archaeology, a little bit of digital humanities. But when Christine and others were putting together the ActivityPub conference and expecting Christine to organize a conference, it was not going well.
No, nobody was expecting that. I was saying it would not happen if I did it because I just was too overwhelmed.
So I offered to take over the organization for the conference because that is a transferable skill, whether you're setting up a conference for art history or archaeology or Federation standards. And then we had a wonderful episode of our podcast with yesterday's keynote speaker, Alana Hashman and Katie McLaughlin, about the FOSS project Ich, which is a way to make cross-stitch patterns procedurally, basically using the software. So this is a good example where you've got software and FOSS helping to do more traditional craft processes, and then the traditional craft processes informing very complex and interesting software problems.
So another interesting thing about where a lot of different skills are needed are fundraising, which I've had to do a number of times throughout my career. It is my least favorite thing to do, but it is important, right?
I have also had to do fundraising an awful lot over my career as well.
Both on projects that, we've both worked on together or that you've helped with, or also for your own academic stuff.
Yeah,
right?
So for both academic and FOSS projects.
Yep. So for example, writing out a grant application we recently got on, this is not actually announced on the Sprightly blog yet, but Jessica Talon, who co-authored the ActivityPub specification and also was a hire that went all the way back from an outreach program for women intern on the Media Goblin days. She is now coming on full-time to focus on Sprightly using a grant that came from NLNet. But being able to do that also required a lot of, skills that I feel like came from the kind of writing background I had, right? Also, you can combine, why not combine things such as programming and also ASCII art? So Deb Nicholson, friend of ours and also friend to SeaGL, asked me one year whether or not I would help with Software Freedom Conservancy's fundraiser by making a special postcard for them. And I said, oh, sure, I can make it in ASCII art. And then I went completely wild and wrote a program to create an animated ASCII art postcard that they ran on their servers and people could telnet into. But also doing fundraising and doing a crowdfunding campaign required being able to create a video that created compelling reasons for the public to possibly want to donate. And, I had these Blender skills from just picking it up as a hobby, just for fun. And I got to transfer that into, working on that video and creating kind of the abstract descriptions of what the problems were we were trying to solve. And luckily, since I also knew artists, who, especially Bassam Kardali and their partner Fateh, who were willing to take me into their studio and help me train me on the ideas of animation so that we'd be able to pull this off. So, but further than all that,
someone's got to make and ship all of that stuff. Someone has to paint all of those 3D printed badges gold and then do hand detailed color correction on them.
Yes, thank you very much.
And package them and ship them out and wait in line at the post office.
Right. And all of that is effort and skills that
are not programming.
So here we want to kind of extrapolate some lessons in general.
So one skill leads to another. If you have something to contribute to a project, you start off with that, and then eventually you are onboarded and learn more skills that are also relevant and pertinent.
And I think it's important to be able to value a diversity of skills, right? So I didn't tell Deb I was going to do this, but I was...
Sorry, Deb.
Well, hopefully she appreciates it. The Deb Nicholson, who, I don't know if she's on this year, but has been on the SeaGL committee for many years, but is also a close friend of mine and was co-founder along with me of the Media Goblin project. And she was and is an amazing communicator, an incredible community organizer, and an incredible just person to work with in general. And, she would go around and speak about Media Goblin, and people would, come up to her or myself at conferences and say, gosh, well, how do we get a Deb in your project? And I don't know, I guess the thing is when you're lucky enough to have somebody like Deb approach your project, you should treat them as somebody who is, really valuable. And, and we were so lucky. Are you
looking for a diversity of skills for your project, or are you prioritizing certain things over others?
Right. So I mentioned I was working on this comic, and it kind of never went anywhere. I made about 8 comics of it. The last one was just a single panel thing that said this, which was one of the characters trying to say to the other character, well, let's just make the thing, right? And the irony is that that's where I stopped, right? And one of the reasons I stopped was actually fear. I was creating a comic where the characters were starting to talk about some technical things, and I wasn't a programmer, and I was afraid that I didn't actually know enough to be able to, where I was going to say some things that were going to be foolish. They weren't right. I wish I hadn't been so afraid. But on the other hand, even going partway through things, it helped teach me enough to be able to pull off some useful things into the future. So now is the time for creation.
And so the culmination of the last, 15 to 20 years of Christine and I's interdisciplinarity is the podcast that we have been running for the last slightly over a year, Foss and Crafts, which is an interdisciplinary podcast about free software, free culture, and making things together. And it basically takes all of our interests and looks at them, smushes them together, and looks at them all through the lens of user freedom.
And we were kind of wondering whether or not there would actually be sufficient interest externally, but there really has been. And, it's also itself an interdisciplinary project. You have to make the website, and me being me, I decided to make it in Scheme using the Hunt site generator. So you could say that the site itself is a code project. And the intro music, I'm not really good at music, but I decided to try anyway because it felt appropriate for the show. And so I made a song in Milky Tracker, and we have a whole episode of me being very embarrassed trying to explain how the ideas, but also getting into the sound theory that I learned about while working on the on the music.
And then the logo was a combined process, and we really wanted to incorporate both the Foss and the Crafts into the logo. So it started with Christine.
Yeah, so I made a little Racket program that actually built this thing out of ASCII art, and also some image manipulation. And
then I did a needlepoint of it. And then we combined it together using the GNU image manipulation program. And then finally, we have these Hack and Crafts events, which are community events where they're kind of a combination between a user group and a Stitch and Bitch, where we get together virtually. Everyone brings whatever craft project they're working on, and we talk about user freedom.
And finally, we wanted to talk about keeping it fun. So we mentioned that we had just join the little costume contest that was appearing earlier. So this is the Morgan is Brux, and I'm Goblin, which are two of the sprightly characters, but we're low on time. So we just wanted to say thanks, and we are in fact running.
We have a Hack and Craft this evening at, I believe it's 5 p.m. PDT. So after Cory Doctorow's keynote, if you have some time, feel free to pop in and say hi. Thank you.
Thank you.
Thank you. That was Christine and Morgan Lemmer-Weber with a great opening keynote to start our Saturday morning program for SeaGL. Thanks again to our platinum sponsors, Amazon Web Services and JMP. And with that, I encourage you all to check out attend.seagull.org if you're not already there, and start planning out which of our great talks you want to attend today. As a reminder, talks will be recorded and made available afterwards, so if you miss a session, you'll be able to watch it later at your own convenience.
For anyone that doesn't know, we are in Matrix. That's the place to connect to all things SeaGL related. And there is a Matrix channel specifically for this talk. So it's called like Saturday 10:00 free security for open source projects. And that's a great place to go ask questions. We actually will be doing a Q&A at the end. So we'll read your question out loud and then I'll have Dawn here to answer. Or they may just answer you in the Matrix. And yeah, I do want to remind everyone that we have a code of conduct that's available at SeaGL.org. It's a good place to check that out. So, you know, be cool. And I think without any further ado, I want to introduce Dawn Collette talking about free security for open source projects.
Hello everyone, it's good to be back on day 2 of SeaGL, and today I am talking to you about free security for open source projects. If you want to follow along with the sources that I used to put together this talk as I'm speaking, you can go to the GitHub link on the slide at the moment, or scan the QR code with your phone, and it will bring you to a GitHub repository with all of the sources that I used. To begin with, I would like to acknowledge the Wurundjeri people of the Kulin Nation on whose land this talk was recorded, and all other Aboriginal and Torres Strait Islander groups across Australia. This is and always will be Aboriginal land. Their sovereignty was never ceded. I would also like to acknowledge the Aboriginal and Torres Strait Islander mentors that I had growing up, who played a formative role in who I am today. So, who am I? My name is Dawn, and I am a security and DevOps person at Enabler. We're a boutique consultancy in Melbourne, Australia, and we like to solve DevOps problems. So if you like to solve DevOps problems too, we're hiring. Or if you're looking for someone to solve those problems for you, come and find me and I can put you in touch with the right people. I'm also an open source enthusiast, and one of the reasons that I really enjoy working at Enabler is that they're supporting me to be an open source enthusiast. Outside of work, I am an occasional author and kitchen alchemist. Sometimes that ends really well, sometimes it doesn't. I'm also a raging sports ball fan, which is why, sorry Seattle, that's me in a Boston Bruins sweater. So, talking about security in open source, I mean, security in general kind of comes down to a question of design. And there is no one overarching design for free and open source software. It spans everything from the packages that we use when we use a library like React or Ruby on Rails, or the packages that we use when we build small applications ourselves. And then it goes everything to Elasticsearch, full-featured tools like LibreOffice, and a bunch of web tools for all kinds of things. So the way that you interact with the security ecosystem and the way that you use security practices and security tools will depend very much on what it is that you're actually building. And that kind of comes down to, I guess if we have to split it, there's probably one big split that we can have here, and that's open source packages compared to feature-complete open source software. Two workflows, similar in some aspects but different in others, and those are the two sort of main workflows that you'll find around security in open source software. So let's take a moment and put on our black hats and think about how we would actually breach a system. There are a few different ways to breach a system that cut across both of those different types of open source software. Supply chain attacks are always a really obvious one, unless you are building a very, very core package that does not rely on anything else. There is always a possibility that someone will be able to attack your application by attacking an upstream dependency. Then we've got stuff like malicious code injection. If someone can manage to get nasty code into your application, well, jackpot for them and game's probably over for you, because at that point they can breach everyone who's downloaded your package or all of your users. Phishing and social engineering attacks are another fairly critical one for open source in particular, because you're only as secure as the least secure person that's got privileges to your code. And there are many, many more ways to breach a system. We'll cover some of them later on, but these are kind of the core ways that you can breach a system that will apply to a lot of open source. So let's look at attacks that have actually happened. The ESLint one was a really good one. I'm sure that anyone who's worked with JavaScript probably remembers that. What happened was that one of the ESLint maintainers had been using the same credentials that they had used elsewhere, and those credentials had been breached, which were uploaded probably in some data dump somewhere, which resulted to that maintain's token being compromised. And what the attacker did was really clever. They actually uploaded in some of the, not ESLint core, but some of the other packages that were maintained by ESLint, a credential stealer. So it would go in, it would sniff your .npmrc file, and it would hoover up whatever credentials it could find in there and send them off somewhere else. Then there was the Ruby Gems attack, and this wasn't just one package, this was several packages all at once. Now, if you went and you installed those Ruby Gems, you got some free extra software, quite a bit of malware, and crypto wallets and crypto miners were installed with these packages. So that's nice, you get extra stuff for free, the fact that it's taking up a lot of your CPU cycles then notwithstanding. Another really common one, and again this is not one breach but more than one, is the Elasticsearch breaches, and these tend to happen fairly regularly. Now, Elasticsearch itself and the cloud maintained version of Elasticsearch are not awful in security, but it's really, really easy to misconfigure Elasticsearch. And so there have been a bunch of cases where organizations have been breached and they've actually blamed those breaches specifically on misconfigurations in their Elastic setups that have meant that someone's basically been able to go in and yoink all of their personal data. And part of defending against these sorts of attacks is about actually thinking like a malicious actor. So if you wanted to breach your particular open source project, what possible attack vectors might you use? So we've talked about a few things like phishing, social engineering, injecting malicious code, being able to compromise a package upstream. But the other question then is, which are the most likely to succeed? And that's going to depend entirely on the package. If you're producing a feature-complete piece of open source software, then the types of attacks that are the most likely to succeed are going to be completely different to the types of attacks that are going to succeed on an upstream package that's designed to be consumed. But one thing that cuts across all packages, all types of open source software, again, is that often people are the weak point. So you've got to think about things like, are we giving elevated permission to anyone that we shouldn't be? As I've seen from the ESLint attack, if you're not careful about that kind of thing, the more people that you give elevated permissions to, the more risk you introduce. And it's also worth here thinking about other applications or upstream dependencies that you might be relying on, and whether how secure are they, but also whether you've actually given them appropriate permissions or whether they can see far more than they should be able to. And then there's the old question of how hard would it be for someone to execute a phishing or social engineering attack on the project's core team? Because if someone is able to do that, then very quickly they can potentially get access to a hell of a lot of information about what is going on with your project. So I know that this is our free security for open source software, and the abstract does talk about tools. But let's start by talking about free security that you can get without ever touching an external tool. And that comes down to a concept that I'm going to describe as end-to-end system hardening. And really a lot of this is about removing the credential compromise piece and removing the social engineering piece. And as I said before, proper access management is a really critical part of this. But once you're sure that everyone has the exact amount of access that they should, just in time and just enough are two concepts that are really good to look at for this, then you've got to start thinking about how you actually defend against some of these attacks. So password hygiene is a really important thing. Don't reuse passwords. If you possibly can, use a password manager, because then it means you only have to remember one password. And if you need to, if somewhere gets breached and you need to generate a new secure password, that's pretty trivial. And to recognize when breaches are coming down the pipeline, leveraging tools like Have I Been Pwned is really good for this. So making sure that you're actually subscribed to alerts on your email addresses, subscribed to Have I Been Pwned alerts, and that you're checking to make sure that your passwords have never been in data breaches. Another thing that tends to guard against problems even if you don't have perfect password hygiene is multi-factor authentication. Now, hardware keys like YubiKeys are the holy grail of this. You actually have to have the hardware key on your person, stick it into a machine and press a button. But even setting up multi-factor authentication with something like a mobile phone, even with SMS, is vastly preferable to having no multi-factor authentication on there at all. Because if someone is to guess your password, or if someone is to breach your password, then having multi-factor authentication in there will stop them unless they've also got access to the corresponding piece of hardware. And another thing that's important is rolling tokens regularly. Not just access tokens or passwords that you use, but also tokens that your project might use to authenticate to other projects or other services. Making sure that very often, actually set yourself a schedule and go in and roll those tokens so that if they do get compromised, people will only get access for a certain amount of time before it gets cut off. And doing the end-to-end security piece really well does have a time cost. So there is, it takes time to do this properly. But the thing about it is that once you do this properly and you get into the habit, it really will protect you against a lot of the potential security issues that you can run into. Another thing that's important to think about in terms of free security without third-party tools is using secure platforms. And so this is about if you have to pick a hosting platform, or if you have to pick a third party to interact with, try to find a third party that manages security for you rather than leaving it to you. In the commercial world, Kubernetes is kind of notorious for this because it's not secure out of the box. There's actually a decent amount of work that you have to put in to get a Kubernetes set up to be secure. And so a lot of people get caught out that way. And as far as open source goes, there are some really good ones. GitHub has a dependency management tool built into itself called Dependbot, which will warn you if there are any known CVEs in your upstream dependencies, and will actually put in pull requests to your project to update them yourself if it possibly can. Another really good thing that GitHub does is it actually has the concept of code owners for files. So you're able to put in sort of boundaries around the code in your project to say these particular people need to look at these changes to these particular files. And when someone puts in a pull request, then the people that you've nominated as code owners will be automatically, they'll automatically be marked for review, marked as reviewers on that pull request. So GitHub has done a lot of good stuff around security, but GitLab has as well. Except that what they've done, a lot of that has been in the realm of CI and CD. So their CI/CD system, they have actually spent a lot of time integrating free and open source security tools into it, with the idea that then you can turn all of those tools on in their CI/CD without having to go to any extra effort. They're doing a lot of that work for you and abstracting it away. Another interesting thing to think about if you've got to host an application somewhere is, rather than just pulling down whatever the latest release of Ubuntu or Debian is, you can look into hosting things on Linux distributions with hardened kernels that are specifically designed to be secure, or hosting things on stripped down Linux versions, Linux distros that have a lot less bloat in them, and that means they also have fewer attack vectors. And in terms of the secrets management piece, it's always good to look for platforms that will do secrets management for you, or to look for platforms that do secrets management well, rather than you having to go away and do a lot of that secrets management work yourself. So if you're looking for, say, a CI/CD provider, make sure that they have features to store your secrets, and make sure that those features actually keep your secrets secure and that they're not being leaked as a result of that. So that then brings us to what some might consider the crux of this talk, which is the free security tooling. Now, there is a huge amount of free security tooling out there, and it falls into broadly two different categories. The first one is security tooling that's actually open source itself, and there are a lot of applications there. The second one is security tooling that, while it is closed source and is typically paid for, has actually presented itself as being free for open source projects. So let's look at the open source security tooling first. In terms of static application security testing and dynamic application security testing, there are way too many for me to detail here. But the OWASP project actually maintains a list of SAST and DAST tools. It's in the sources. And although it includes both commercial and open source tools, it specifically highlights the open source tools as being open source. It also has some degree of highlighting where things are free for open source. So definitely go away, if you're interested in the application security testing piece, definitely go away and have a look at all of those tools. Now, if you are hosting anything in the cloud, another important thing to look at then is actually scanning your infrastructure as code. And there are a couple of different open source tools for that. One that I've used really extensively is Chekhov, which deals with all of the big cloud providers and also scans Kubernetes stuff. But if you're looking specifically at Terraform, then there's Terraformer, which is designed as a security scanner specifically for Terraform. There are other options for IAC scanning, but those two are probably going to cover off the vast majority of what you would need. Then, another thing that we can look at here is image scanning. And for image scanning, hands down the best option is Claire. So Claire will basically go through, it will scan any Docker images that you are using as part of your project, and it will let you know if there are any vulnerabilities in them, and it's also configurable. So you can go ahead and tell it exactly what level of vulnerabilities you want to look at, get it to ignore vulnerabilities. Like many other tools, it can be built into your pipeline. Dependency management is another fairly important piece, and we've talked about Dependabot already, but OWASP has actually released some tools for this themselves. They've got dependency check and dependency track. Slightly different use cases, but between the two of them, that will cover a lot of the potential issues that you might run into around dependency management. There are also a bunch of other tools that don't quite fit into any of these categories. And I want to highlight specifically 3 here, which are not necessarily going to be as useful to you if you're building a package, but will probably be useful to you if you're building feature-complete software. So the OWASP Zap is a pen testing tool, an open source pen testing tool, and that will run against a lot of common CVEs and a lot of really common attack vectors. If you're doing anything web-based, then Wireshark is an open source tool that allows you to do packet scanning, so you can see if there's anything going on that looks atypical. And if you really want to go the whole hog with pen testing, then there's Kali Linux, which is a Linux distribution that is entirely focused around penetration testing, and it comes with a bunch of really good pen testing tools. These, unlike a lot of the ones that we talked about earlier, are not going to be for everyone. But if you're building feature-complete software, they're useful to have in your arsenal. Now, the thing with closed source tools that are free for open source is there are a huge amount of them, but there are 2 that I want to focus on specifically for different reasons. The first one is SNCC, and the reason why I want to look at SNCC's suite of tools is because even though it's closed source, it's actually a pretty comprehensive set of tools that you can get for them that are all effectively free for open source. They obviously don't provide you with support around that, but if you do want to use those tools, they're there and they're free for open source. And having all of that in one place can save you the difficulty of having to go and pick specific open source tools to help you manage different parts of your security. The other one that I want to look at is Debricked, for the very specific reason that if you look at the tools that OWASP recommends, Debricked has one of the highest true positive rates and one of the lowest false positive rates of basically scanning tools that are out there. So if you're looking for something accurate, The fact that Debricked is free for open source is really good for you there, because it actually enables you to go in and be fairly confident that the alerts that you're getting are alerting on actual problems, which saves you from potentially having to go down rabbit holes around solving issues that aren't really issues. So we've come to the end of the talk now, and before we finish up, I want to briefly come back to that sort of idea that we talked about at the beginning of packages compared to feature-complete software. Because where you do or do not integrate a lot of these tools into your workflow is going to depend on what you're actually building. The other thing is that the potential set of people who can be compromised differs depending on what you're building as well. So take some time to think about, put yourself in the shoes of a malicious user, and think about, if you wanted to attack your piece of software, how would you go about it? So we now have some time for questions. If there's anything that I don't get to, then you can contact me on the contacts that are up on the screen now. Thank you for coming along and listening to me talk about free security for open source projects, and I am very much hoping to hear about a lot of you using these free security tools in the future. Thank you.
Awesome! Yay! Clap, 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 clap. Thank you so much, Dawn. So I'm going to add Dawn to the stream now, and I see that there was at least one question around CI and CD that I think Dawn is going to expand on.
Hello! I'm assuming that everyone can hear but not see me now. So there was a question that was asked about what CI/CD actually stands for, which is one of those great tech buzzwords. And the short answer is that CI stands for continuous integration, and CD stands for continuous deployment or continuous delivery, depending on when you're talking about it. A continuous deployment basically being you can click a button to deploy, continuous delivery being you can do the whole thing end to end. And the reason why that is important for this concept of sort of free security for open source projects is because obviously you don't want to have more overhead than you need. So if you can put stuff into pipelines, which are effectively what CI/CD is usually means in practice is basically you set up pipelines to do all the work for you. And if you can put that stuff into your pipelines rather than you having to do it manually, it takes away the thought of it, which is why it's important to this.
Cool. I guess I'm not really seeing a lot of other questions in the matrix. So I guess anyone speak now, or I think we might wrap it up. And of course, if you think of anything, after we end the video, the matrix channel will still be there. So feel free to drop a line. But yeah, I guess before everyone logs off, and I'll check for questions once more before formally ending. But I do want to thank our platinum sponsor, JMP, for sponsoring SeaGL and Track 1. And then up next at, I believe, 10:50, yes, 10:50, or no, 10:45 Pacific time, we're going to be having another round of talks, at least in Track 1. It's going to be building cloud networks, Terraform, or Ansible. Oh, sweet. We did get one more question. So is there any software you would recommend for sharing secrets selectively between groups? Sharing passwords via emails has its flaws.
So this one is a little bit harder. And the reason why this one is a little bit harder is because it's actually, there are a lot of tools for this, but most of the good tools either have a huge effectively overhead cost in the setup, or will cost you enormous amounts of money. Because you can do secret sharing through things like password managers, but in order to do that, you're generally looking at having to pay them, organization money, if not enterprise money, and that can be really prohibitive for open source groups. So my approach there has been generally to go with platforms that'll do it for you. So like a good CI/CD platform or a good pipelining tool that will let you abstract away all of the secrets related to that. But the problem is that there are other ways of handling secrets where they never touch the pipelines. And obviously you don't want to be sending passwords for things around via email. So if you use password managers yourself, you can leverage that. As far as good tools, maybe a HashiCorp Vault or something along those lines has some utility there. But even then, you're going to have to find a place to host it, and you're going to have to actually set it up. I don't know if there's a cloud version of that that's free for open source, but that is something I should probably go and check. Oh, hello. And someone's actually answered the question about sharing secrets securely for me. I think I'm going to have to actually go and put that one in the sources.
I know, I have not heard of YoPass, but I'm very interested.
That is very, very useful. And yeah, that sort of the YoPass looks reasonable for the sort of use case that private bin is often used for within a lot of organizations. But if you can't quite do the secrets management bit properly, anything that will allow you to send secrets and burn it is better than sending them via email or via Slack, where there's always going to be a record of it. So those links are excellent, and I'm going to immediately go and put those in the sources. Then I'm going to go and get some sleep.
Oh, someone asked a good question. Is Matrix secure for chat?
To be honest, I don't really do a lot of the sort of social media type discussions in general, but from what I've seen just from playing around with it for the past 2 days, it's pretty good. What you're probably looking for, and that's actually something, there was a lot of scope that I could have looked at in this talk, but I had to keep it fairly contained because obviously, you could do a whole hour's worth of talk on this. But from what I've seen, Matrix is pretty good. And probably what you're looking for is just to not be leaking all of your communications over the unsecured internet. So anything that has effectively encrypted messaging features is going to be fine for you. Where you run into problems, I think, with the discussion pieces, if you're doing it all, say, over IRC, you've set up your own IRC, and you've not done a lot with access controls, and you're trying to do it with security over obscurity, Matrix absolutely looks like the better option for that.
Yeah. Wow. Cool. All right. Well, I know we've got 5 more minutes until the official end, but between me and the audience, I think we should let Dawn go get some sleep. But thanks everyone for such good questions and for being so engaged. And like I said, we'll still be in the Matrix channel, at least for a little bit. All right. Well, thank you so much, Dawn. This was really a really awesome talk.
Anytime. I'll be back around in about 4 or 5 hours, and I'll pick up anything that's put in the chat then.
Yeah.
And I'm going to go and put a bunch of the things that people have just shared in the sources.
Awesome. Well, sounds good. Thank you so much for joining us.
Thank you. Goodbye.
All right. Yeah. Thanks, everyone. Going to end the broadcast. But yeah. All right. See y'all later. Doodle-doo. I know it takes kind of a while to cut over. Oh. Oh, awesome. All right. Here we are. Hi, everyone. Welcome to Building Cloud Networks, Terraform, or Ansible. As usual, we will be having all the questions go into the matrix. And do keep in mind there's a code of conduct, which you can check out at SeaGL.org. And yeah, so put all your questions there, and Troy and Francois will be answering them. So without further ado, I want to introduce Francois Kane, Troy Perkins, talking about building cloud networks with Terraform or Ansible. Take it away.
Thanks, Lucy. Good morning, everyone, if you're in the Seattle area or in the same time zone, and good afternoon or evening if you're somewhere else. We are here today to talk about cloud network automation. We're going to start, Troy and I, with introducing ourselves real quick. We're going to talk to you a little bit about the world of networking, NetOps, and to be fair, what's wrong with it. We're going to talk about NetDevOps, which is that merger of DevOps and networking, and the tools involved in that. And we're going to spend a good half of this session with a live demo, showing you a little bit how we can use NetDevOps tools to build cloud networks in a modern way using modern DevOps principles. I want to warn you about something. Troy and I were both network engineers. And you may not be, and we don't expect you to be, but that means that we use our own jargon. And I apologize in advance. We're now and then we're going to talk about GRE and ZTP and other things like that. When we do, please ask in the Q&A, because fortunately there's two of us, which means that at any given time, one of us will be talking to you, the other one will be monitoring the Q&A. So if you have any questions, don't wait until the end. Ask it live, and we'll respond to you either in chat or live in the video. And please don't be shy to ask us questions. So who am I? My name is Francois. I'm in Washington State. I used to run the GNU+Linux users group, and I've been involved in the open source community for a little bit over 20 years now. I wrote some books on Linux about 15 years ago, and I transitioned towards becoming a network engineer also about 15 years ago. And I joined Cisco 6 years ago, and I now work on programmability and automation at Cisco on related mostly to networking and clouds and that sort of stuff. Troy, go ahead, introduce yourself.
Yeah, my name is Troy Perkins, and I'm in Evanston, Illinois, just north of Chicago. I'm currently a systems architect at Cisco. I've been here for the start of my 4th year. Prior to that, I was actually in the high-frequency trading sector here in Chicago from 2012 to 2018 as a senior network engineer. And over the years, I mean, I think all the way back to 2006, 2008, I've done some form of automation, everything from screen scraping to where we are now. So a lot of my knowledge has been built over the years and what works and what doesn't. So looking forward to doing a demo today for you. Francois?
Thank you, Troy. So let's start talking about what's wrong with traditional network engineering, because we can call it NetOps to make it sound cool. It's still not perfect. And I'll start with an anecdote. When I Googled NetOps meme, the first result I got was this one right here, which is a joke about how slow network engineering is. What's happened in the past decade, roughly, is, well, DevOps happened. And DevOps means that we went from the server teams and the application teams being able to deploy new application and scale new applications in seconds, minutes, sometimes hours, but that's the kind of time frame we're working at now. Whereas 10, 15 years ago, the server teams and the networking team both would take weeks, months to deploy new application. You had to rack the server, you had to power it, you had to connect it to the network, connect the switchboards, change the VLAN, open the firewall, connect the load balancer. Thanks to DevOps, the server, cloud, infrastructure, application people have accelerated all this with VMs and containers. And then they turn around and they look at the network team still sitting there in the corner, like, okay, network team, can you turn this up in the next 17 minutes for us? And the network team goes, well, we're going to need 2 weeks. So that's the problem. That's been a problem. And the way we network engineers are trying to address that is we look back across the table and we just look at the tools that the cool kids are using, the DevOps kids are using, and we look at the Ansible and the Terraform. We're like, hey, maybe if we use those tools, we could be as fast as those people. So that's kind of the problem statement that leads to this discussion we're going to have today. NetOps is still really behind the rest of the DevOps world in most cases, in most organizations. And when NetOps talks about automation, it's still mostly a discussion about automated configuration management. It's still a discussion about pushing config statement to 1,000 switches, as opposed to a discussion about provisioning infrastructure really rapidly, iterating infrastructure really rapidly. We're not there yet. So that's where we come from. Let's talk about how we can fix that. There's an analogy that's existed in the DevOps world for at least a decade, which is the analogy of pets versus cattle. The whole idea is that server and network engineers traditionally have treated each individual server, router, switch as if it was a pet, giving it a specific name and fine crafting the configuration and not scaling at all, because it's a very love-based endeavor. Whereas the DevOps world has taken the cattle approach, which is you have hundreds of them. If you need 100 more, you spin up 100 more. When you're done with them, you get rid of 100 of them. And you don't give them individual names, and you don't feel love for your infrastructure because it's just there to do a job for a short amount of time. So I think the way we network people can fix our approach is by taking that whole cattle approach, that agile DevOps approach, doing sprints, using tools like Jira, which the DevOps people use, and more importantly, managing our infrastructure with two tools which have been used that come from the cloud DevOps world, which are Ansible and Terraform. So I'm going to assume, I know we always have in an audience like this a wide mix of experience. I'm going to do a quick introduction to Ansible and Terraform for people who don't have exposure to it. Ansible, they're both open source tools. I should start by saying that. Ansible was acquired by Red Hat, which was acquired by IBM, but they're still a very much an open source tool with a very vibrant community. And it's one of the things that has allowed Ansible to be as successful as it is. I'll give you a measure of success. 75% of network engineers use Ansible today. And in the server DevOps infrastructure world, it's probably in the same ballpark, if not closer to 100%. The reason why people use Ansible so much is that Ansible can manage and automate pretty much everything under the sun, because it was built to be modular. It uses modules to automate things. So if you want to automate an Ubuntu server, there's a module for that, and it'll connect to it and it'll do things to it. And you don't have to write that. Somebody else in the community has written that. If you want to automate a Cisco router, there's a module for that, and somebody has written it. So that's the basic approach of Ansible. It's very highly modular. You have this core engine which reads config files. It's your traditional, Unix tool. You write config files in text files, and you run Ansible typically originally from the command line. When you scale it at enterprise scale, there's other ways of doing it. But when you get started, you run Ansible on the command line. You run what's called playbooks, which are text files written in YAML, and Ansible will go connect to your infrastructure and do things. And this is a tool that has been seeing adoption in the network world for about 5 years now, to the point, like I said, that a lot of people use it. And a lot of people in the network world use it mostly for simple config management. People don't use it to set up entire cloud networks because Ansible has this approach of doing tasks in sequence, plays in a playbook. But if you want to do complex things, you have a lot of steps, and it becomes complicated to do complex things. Ansible allows you to scale horizontally, meaning you can do one thing 1,000 times really well. But it doesn't reduce complexity. If you want to do 20 things 1,000 times, it's 20 times more complicated than doing one thing 1,000 times. I'm oversimplifying a little bit, but that's a bit of the concept there, which is why Ansible does config management at scale very well, but doesn't do complex operations as easily. An example for us in the network world would be a software upgrade on a switch, for example. That's a somewhat complex operation. it can be done in Ansible, but it can be painful and difficult to do in Ansible. And in the world of cloud networking, where you actually have to create infrastructure, provision infrastructure out of thin air in order to configure it, Ansible can do it, but it's not the best tool because Terraform is the better tool for that. So let's talk a bit about Terraform. Terraform it's been out, initial release in 2014. And in the cloud world, it's been popular for several years. However, in the networking world, it's a very new tool. Adoption has just started about 2 years ago. And most network engineers look at it today and ask themselves, should I be using this? The reason for that is Terraform, it's made by a company called HashiCorp. It's also an open source tool. It's designed to provision infrastructure out of thin air. For example, it's designed to connect to AWS or KVM on your on-prem hypervisor and spin up VMs, create networks that didn't exist before. It's not designed to just push config, it's designed to create things. And then after that comes the discussion of how you configure them, and we're going to show you how to do that. HashiCorp is written in Go, whereas Ansible is written in Python. That doesn't make a difference. Those are both good things. I don't think personally one is better than the other. And the way Terraform works is somewhat similar to Ansible from a modularity perspective, in that you use what's called providers. And providers are what allows Terraform to connect to infrastructure and configure it. So if you look at the way you do that, it's the same thing as every other Unixy thing. You edit files, text files, and then you run Terraform. And the language that you use here is called HCL. It's not radically different from using a YAML or JSON or one of those things that are both human and machine readable with brackets and lines. Those things all kind of look the same. Of course, they each have their own syntax. And if you go look on the Terraform provider registry, which is the Terraform website, you'll see the kind of things you can automate with Terraform. Front and center is cloudy things, as you can see, AWS, Azure, or Google. And then there's a few little things below that for networky stuff like Cisco firewalls and routers and that kind of things. So the workflow of using Terraform is first you create your configuration files, then you initialize it, which means that you tell it to download the things that it needs to work, the providers. Then typically what you're going to do is you're going to do a Terraform plan. That's the command on the command line. And that's going to have Terraform calculate how to go from current state to end state. Terraform is stateful. Ansible is not stateful, so that's an important differentiation. And what you describe in your Ansible configuration file is the end state that you want. Unlike Ansible, where you tell Ansible, hey, here's 20 steps to go from where I am to where I want to be. You tell Terraform, here's where I want to be, and Terraform will calculate in the sense of path calculation. It will literally calculate the steps to get there, and it will tell you, here's what I'm going to do. Are you okay with that? And if you are, you can do apply, and then you run it. And then Terraform goes and does and creates its thing. And we're going to show you a demo of this. And when you're done with your infrastructure, Terraform, because it's stateful and because it remembers what it did, it can undo what it did. So if you do Terraform destroy, Terraform will be like, okay, I know your state. I know you don't need it anymore. I'm going to tear it down for you. And we'll show you that too. That's it. Let's look at the demo. Fine.
All right.
Take it away.
I'm going to go ahead and share my screen here. All right. Let's wait for a second for it to come up here. I'm still seeing your screen.
Okay, I stopped sharing. See if you're able to do it now.
Let me go ahead and start it again.
Okay. Do we have any questions in the Q&A that came up?
I haven't seen anything yet.
Okay, cool. I'll be keeping an eye on the Q&A. So folks, don't be shy about asking us questions, okay?
All right, there we go.
Cool.
All right. So as Francois was talking about, we're going to start this demo, and I'm going to use probably, like he said, a couple of terms, and I'm going to try to use them interchangeably. But we're using virtual Cisco routers called CSR, Cloud Service Routers, 1000 Vs. Might use that interchangeably with virtual router. I'm also going to use the word resources a lot. A resource is just a simple infrastructure as code to create something that we need, whether it's on our on-prem or our cloud instance, and that could be a hard drive, memory, the VM itself. And then interchangeably, I'm going to use AWS and public cloud and KVM and private cloud. So just going to kind of warn you if I go back and forth. But we're going to start here, and we're going to see that Terraform actually doesn't have any state. We haven't created anything yet. So what we're going to do is we're going to kick this off. We're going to skip the plan because I know it works, and we're going to go straight to the apply. The reason why I'm starting this off right away is it's going to take probably about 4 to 5 minutes to create everything. So while we're doing that, I'm going to kind of show you what's happening. So without getting into details, it's going to be creating all these resources that we need. If I move over to AWS, notice I don't have any VPCs. If I go over to EC2, which are VMs in AWS, I don't have anything running there. If I move over to my on-prem KVM, I don't have any.
The diagram of what we're doing real quick, maybe describe a bit our lab while we're.
Let me go kick this off so we can get it running, and then we can show it. And then on the KVM side, we don't have anything running right now. So we're actually going to kick this off. So right now, it's actually going to start creating all of our necessary resources, both on-prem and the public cloud. Francois, do you want to head and go and share your screen since you have it up while this is running?
Yeah, absolutely. Let me see if it works. Sorry for the back and forth here.
And while he's bringing this up, just be aware that on our AWS side, we don't have anything created. So I, as a network engineer, I'm having to create all the necessary resources, which is the VPCs, the EC2 instances, the private and public subnets, ACLs, everything I need to do to get that virtual router up and running and get access to it.
Troy, are you able to see the diagram that I'm sharing?
Not yet. Okay, there it's coming up right now. So here's a very high level overview. On the left side, very simple on-prem. I'm just creating our virtual router and bringing it up. On the right side, again, because I don't have anything previously created, I'm creating everything from the VPC, availability zones, everything I need on that side. And what we're going to do is that's going to be considered our day 0 configuration, just to get the routers up and running. Then what we're going to do is we're going to kick off Ansible playbooks to do our day 1 configuration to get the devices to where exactly what we need to get them running, which is creating a tunnel, a GRE tunnel between the two routers. Unfortunately, because of I'm on a consumer internet provider, I'm not able to complete that tunnel, but at least we can push the configurations over. Francois, you want to stop your share?
Yeah, and let's talk real quick about the problem that we're solving here. The scenario we're addressing is you're an organization that has data and application tiers in multiple clouds. You know, you may have some data on-prem, for example. You may have a front end or mid-tier in AWS. You may even have things in multiple clouds. What we're showing here is the fact that using the same tool set, Terraform and Ansible, you're able to deploy routers, virtual routers in this case, in all the different clouds the same way, and then connect them with tunnels for the data to go between them. Troy, do you want to talk about this slide now, or do you want to come back to this one later?
We'll come back to it later. So because we're right in the middle of the resources right now, Terraform has actually created all the resources. Everything has been created, but they're actually booting up our virtual routers in both AWS and KVM. So right now, everything is working as expected, but we still can't actually do our day 1 configuration. And since my KVM is a bit slower than AWS, I'm actually trying to SSH into my local router to do the actual day 1 configuration, which is going to be our Ansible. So now if I go back here, if I look into see the virtual router on the KVM side is now running, it's up and running. If we come into the VPC section for AWS, we see the VPC has been created. We now have a Terraform Cisco demo. I'm not going to show you every piece of resource created, but let's go into EC2 instance. Notice my VM is now running. So the difference between the virtual router on AWS and KVM is very important. On AWS, we're using the marketplace to pull down the Cisco CSR 1000V router with the bring your own license model. So we're letting them provide that resource. On the KVM side, because that's on-prem, if we look at our files in our Terraform folder, I'm pulling a qcow2 file to actually boot the virtual router on the on-prem. Now you notice we have a bunch of Terraform state files. If we run Terraform state list, we now have resources created both on-prem and on the public cloud as a resource, and it's managing it. So right now everything is up and running. I also have two files. I have for the Terraform tf main.tf and variables.tf. This is actual infrastructure as code from the Terraform point of view. Now, I'm not going to go into complete detail on this, but as Francois said before, I'm using two providers, which is AWS and libvirt, to manage my resources on both sides. And then what I'm doing is I'm using a local variable called routers for my local router creation. Right now, I only have one entry in here, but if I were to add 5 of them, that would create 5 routers on the private side. On the public side, I would do a couple other configurations, but I'm just going to scroll down here real quick.
Charlie, one second real quick. We have a question from the audience, which I think this is the right time to answer. Lucy is asking, are virtual routers widely used rather than physical devices, or is what we're doing with virtual router bleeding edge? And are there pros and cons between the two? I'll take a quick stab at it, and we can talk about it if you want. The answer is it depends where in your network. If you look at enterprise networks, there's networks that live in the data center where the applications are. There's networks that live in branches. Let's say you're a bank and you have 200 branches, you have networks there. You have networks in office buildings. And depending on where you are, you're going to see more physical routers or more virtual routers. For example, if you have a branch, typically the router is a box, right? Because you need a piece of hardware over there to receive the internet and do things. But if you're in a data center, depending on whether it's your internet connection is typically going to be a big router that does BGP. But if you're in a place where your applications live, either your private cloud or your public cloud, then you're going to see more virtual routers because you need more of them. And they don't have to push that much throughput, unless you have some massive application. If you're doing up to a gigabit per second of routing and you have an application living in a cloud somewhere, a virtual router makes probably more sense there. Troy, what's your take?
And to kind of exactly true. And to add to that, whether you use a virtual or physical, and what path do you go? If you're a startup and you're full of DevOps engineers, you may not have the Cisco knowledge or another vendor knowledge of those configurations. So you may stick to the router or the basics that AWS or Azure provide you. Now, if you're going to a net DevOps like Francois and I are, we're used to this configuration. We now can take the power of our Cisco routers, configurations that we're used to, move the physical into the virtual, into these public and private clouds, and use the tool set that we're already familiar with and now make it more agile. So it just depends on where your business is and where your skill set is. So for time's sake, we now have created all of our resources. While we're talking and doing a few things, all of our resources we created, 20 have been added, both between AWS and KVM. Once that happened, Terraform was able to reach our on-prem virtual router. When it was able to do that and it knew we can get to it, said, hey, Kay, my day 0 configuration is done. I can now start the day 1 configuration. And what it does is it's going to kick off 2 individual Ansible files, and this Ansible playbooks using KVM, GRE, and AWS. And what it's doing is it's using Ansible to connect to each virtual router and do a further configuration of what I'm doing the GRE tunnel. Once that was done, it said, hey, everything's great. Here's the public IP address for AWS, because if you're familiar with AWS, you don't know that public IP address until it's created, unless you do something else. So to show you everything's working, I'm now able to ping my internal KVM virtual router. I'm now able to ping my AWS router. And what I can do to show, we can actually SSH into the AWS router. Show that's been created. If I do show IP int brief, tunnel 0 has been created. This is what Ansible actually configured. And if I just do a quick little check on this one, that's the configuration I pushed over. This is key. Same thing for on-prem. I SSH into it. I can show the same thing has been created on this side. Now, the reason why I say that's key, if I come over into our files here and pull up one of the Ansible files, let's do KVM. Notice I'm specifying a few hosts for KVM routers. I'm providing some variables on how to actually get to that particular one. But then I'm using our Ansible iOS module that's under, I think it's ansible.netcommon.network_CLI. And I'm using iOS config to push configs to both my AWS virtual router and my KVM, namely creating a route to the GRE tunnel to the other side, creating a loopback interface for that GRE tunnel, and specifying IP address, tunnel source, destination. So that's my day one configuration that was pushed over to our virtual routers. Let's get out of here. So again, we're done. Terraform is now, again, if we do Terraform state list, it has state. Everything is currently running. If the tunnels were actually configured and able to connect to each other, traffic would be going back and forth. Everything is great. Let's say this was a net DevOps test and we want to see if we can bring up 2 routers, bring up a required tunnel, pass traffic, and tear it down. We're done now. So to Francois's point, we don't need this anymore. There's no reason to incur costs on AWS and take resources from KVM if we're not needing it right now. So we're going to do a destroy. It's going to say out of all these things, 20 things are going to be destroyed. Now, if we move over to our on-prem, that VM has already been destroyed. It's already gone. If we come into AWS, it's now tearing down that VM. If we stay within AWS and we go to the VPC section, which is all of our route tables and all that fun stuff, that's already gone. So according to everything Terraform, both the on-prem and the cloud, public cloud state is done. We no longer have these resources available. Now, before I pass it back to Francois, think if you're a network engineer or you're trying to do a net DevOps, how does this apply to what regular DevOps are doing? If DevOps teams are using, let's say, Jenkins for pipeline, pushing code via Git up to a Git repository and then kicking off a CI/CD pipeline, we now can integrate as network engineers into that process to be able to say, okay, a developer wants to bring up a new app. Well, let's bring it up. They can create the resources that they want to do. We can create a virtualized router, namely Cisco, that we're familiar with, be able to do our policies, our rules, our routes, and integrate into that as well. Francois?
Thanks, Troy, for the awesome demo. So yeah, the cool thing with what we showed you is that we showed it to you with 2 different hypervisors, one in the public cloud, one on-prem. Of course, we use KVM because we're open source guys here. The reality is if you were to do the same thing over multiple other clouds, Azure and Google and ESXi, VMware, locally, that sort of stuff, you would use the exact same tool and your complexity would actually not increase. That's the power of the tool set we're showing you. And if you were to do 100 of them instead of 1 of them each where your complexity didn't increase. So we'll make the slide available at somehow. I'm not sure how this conference does it, but we actually have a few diagrams that explains what we did. And I'm going to just close with the answer to the question every engineer is asking themselves, Terraform or well, why not both? Thanks everyone for coming, and we're going to be hanging out in the Q&A. Is there any real questions before we leave for talking?
I just have one comment saying thank you for providing KVM as well. And I was just making a comment myself saying that, my internal lab that I do all this stuff for, I have both. So I do VMware and KVM.
Thanks, Troy.
Oh, awesome. Wow. Thank you so much to both of you. That was super interesting. And I had no idea about all this NetOps stuff. As always, the Matrix channel is going to remain open. So it's a great place if we have more questions. And we are just about right at time. So I'm going to end the broadcast. But really quick, I want to thank our platinum sponsor, JMP, because the conference could not happen without them. And we have another session coming up, I believe, in about 10 minutes. So thank you to Francois and Troy.
Thank you.
Yeah.
my talk. So this is great in comparison. I'm live.
Hello, welcome back to the afternoon session of SeaGL 2021. In track one right now, we have Brian Callahan giving a talk on stories from reviving and extending a university's information security program.
All right, so hello everybody. I would like to welcome you to the talk, Stories from Reviving and Extending a University's Information Security Program. What I'm going to talk to you all today is about kind of the realities that come with educating and mentoring and bringing into the fold the next generation of both IT professionals and then more specifically information security professionals within IT. So a little bit about me. I'm a lecturer and the graduate program director for the Information Technology and Web Science program at Rensselaer Polytechnic Institute, which is in upstate New York, just outside of Albany. For our younger students, our sophomores, I teach the web development courses. It's a full year sequence that they take with me. For the juniors, seniors, and graduate students, I teach almost all of their information security courses. So if you are an IT information security person, you see a whole lot of me during your time at RPI. And I also generally oversee what we call our major concentration. So within IT, you can specialize in a wide variety of things. And I'm the person who oversees those specialties, both for information security and what we call STS, which is our multidisciplinary sociology, humanities, history, that kind of stuff. So some things I want you all to take away from this talk is to maybe adapt and adopt some of the activities and strategies from me and my stories to your own organization, just to give you an idea of the reality of the difficulty of good security awareness sometimes. Also have us think about how might mentorship look in your organization. And for those of you who might be interested in teaching, not just at the collegiate level, but even maybe younger students as well, some insight into the challenges you might face. I'm kind of listening to both all the things that I might have done wrong over the last 3 years or so, and maybe some of the things that I did right. So let's set the stage a little bit. So it's January 2019. You get your first job out of graduate school, your first academic position. And the person who's hiring you tells you that, by the way, you're going to be effectively in charge of all of our information security students. We haven't really done anything in information security in the last 5 or 6 years or so. We do have a single course that we teach in information security, but it's old. I think the last time it was updated was 10 years ago. So good luck. Oh, and by the way, your start date is January 1st, and the first day of classes is January 10th. So I hope you can put a course together in 10 days, because you have to go live January 10th, whether you're ready or not. But it wasn't always this way. That's a little extreme, but it turns out I didn't actually have to start from nothing. It turns out that we'd actually had a very robust information security program at RPI in coordination with the US Navy at the graduate level. And so naval officers could come and they could either specialize in red teaming or blue teaming, what we had called information dominance or information security, or information assurance. And so I had some of these materials to work with as I was kind of redeveloping, revamping, and really in a lot of ways starting from ground zero, right? Totally from scratch when it comes to reviving this pretty dead information security efforts at RPI. So I got a bunch of old course materials from the last time the information security courses were updated. It did not take me very long to see just how outdated they were. Right, I was going through old slides and old materials from that course, and I had seen a lot of information that was talking about the state of the art back in 2010 or so. And I saw other slides that would say things like, oh, the latest state of the art is OpenBSD enabling WXORX operating system wide. And it turns out I am an OpenBSD developer. And so I know the dates on a lot of those things. And they weren't particularly, new back in 2010. So I figured I really did have my work cut out for me with that stuff. I also inherited a bunch of students. So it turns out that just because the information security program was kind of had already been sunset, there were still students around who were still interested in information security, who were actually, their concentrations were in information security. I had about 6 students when I first started. And so I had a responsibility to them as well to give them the best that I could with whatever time they had left at RPI. And I also had a really good working relationship with our CTF club at RPI, known as RPI-Sec. And so I had a couple of resources to work with as I was getting started. So while I didn't totally start from nothing, with a short 10-day, right, from hire date to first day of the semester, plus really having to rewrite that flagship course from scratch, it sure felt a whole lot like starting from nothing. So what do you do if you get thrown in a position like this? Well, first thing is you panic a little bit. Second thing you do is wonder what exactly you just signed up for. And then you get to work actually doing it. So I read a whole bunch on how to teach InfoSec. So importantly, right, I think a lot of us, no matter where you are in IT or open source or computing, knowing something and being able to teach that thing are really not the same. I know there's that oft misquoted quote, which is those who can do, those who can't teach. But the actual quote from Aristotle is actually those who can do, those who understand teach, right? Kind of hinting at the fact that it takes more than just ability to be able to transfer your knowledge to somebody else. I also had to read a lot about InfoSec because I don't think anybody is a true expert in everything that exists within the broad domain of InfoSec. I certainly am not. Right, so I too had to pick up things that were kind of outside my direct domain of expertise. Fortunately, I found that there's a whole lot of people thinking about how to best teach InfoSec to the next generation, right? So I'm not totally starting from scratch, and you would not be totally starting from scratch from that perspective, right? There are lots of people thinking about how to do this well. I also discovered there's a whole lot of misconceptions out there about what actually constitutes information security and information security education. One such misconception that I had to deal with at RPI when I first got started is that everybody, or at least most of the students, thought information security was just red teaming. And of course, there's a whole lot of stuff out there that is outside of the domain of red teaming. Not that red teaming is not interesting and important, and I certainly teach classes that focus on it specifically, but there's a whole lot more out there. If you're interested in reading what I read to get started, maybe with your own InfoSec teaching experience, after the talk, I'll have all my contact info. Just shoot me a message. Happy to send that bibliography out to anyone who's interested. All right, so task number 1 was to create new courses and revive the course that already existed, right? So this is our InfoSec course. This was that flagship course that I had inherited, that I had gotten all those old materials from. And I was specifically tasked to make this a course that was all things to all people. And that's a basically, Herculean task. You can't really ever quite do it. So what I ended up settling on was dividing the semester into thirds. So my first third was about getting us up to speed on baseline vocabulary and kind of baseline concepts that would take you very, very far in InfoSec, no matter where you might end up in InfoSec for a career, right? So getting a baseline vocabulary, talking about baseline tools and technologies, things like access controls, things like risk mitigation, things like IDSs, IPSs, firewalls, right? Things that no matter where you ended up in InfoSec, you were probably going to be putting your hands on at one point or another. Second third of the semester would be on secure coding, and this is kind of more in my specialty area. So we would look at classic examples of buffer overflows, classic examples of other worms, other viruses, other malware, and begin to talk about how we could defend and code against those things, or make our code better to not fall victim from those particular things. Right. So everybody in InfoSec, they all get to leave the semester having actually done their first buffer overflow exploit, and the students are always very excited to see the machine do something that it wasn't originally intended to do. And then the third of the semester, we focus on people. That could be anything from how to get buy-in from employees for security awareness trainings, through to and including ethics, through to and including the geopolitics, right? The ever-evolving geopolitics of information security. Is that all things to all people? Probably not. I'm sure there's a whole lot of things in there that other people would say you absolutely have to do. But I found it is enough things for enough people that this kind of revamped course seems to have worked very well, both with our IT students directly and also with the computer science students, who I get a couple every year when they come take InfoSec. Second course would be this course called MBE, which is short for Modern Binary Exploitation. This is a red teaming course. We actually work with a company that's founded and run by RPI alumni. It's a platform, so those of you who are familiar with either IDA Pro, Binary Ninja, Ghidra, any of those, it's a web-based app that looks a whole lot like those, gives you a built-in debugger, gives you built-in panels to read code in C, and then the translated code in assembly, and it gives you a space for you to type in exploits in Python to then be fed to those programs. And so that takes students all the way from kind of the basics of red teaming, reading code, reading assembly, doing reverse engineering, through to and including rock chains. So students come out of that course kind of having a good set of fundamentals about where to go next for whatever it is they want to do in terms of red teaming. And then the third course that's new for this semester is a certification course using the ISC Squared's SSCP exam as the model. So we do, a full kind of 16-week hands-on course on everything that goes into that exam. And then also extend what's on the exam as well, right? Not just being able to repeat back theoretical knowledge in a multiple choice, as that exam is, but also get some hands-on experience. So every chapter, we do one chapter a week. Mondays, because we meet Mondays and Thursdays, Mondays are usually a lecture for me on all the material. And then Thursdays, we do something hands-on that extends our knowledge. And this course has been very exciting for me, right? I haven't yet finished teaching one full semester yet. I will at the end of this semester. But I've been really excited to see where the students go, particularly on those Thursday classes where we do stuff that's out of the textbook and actually extending our knowledge. I actually have a great story from 2 or 3 weeks ago. We were doing the chapter on malware, which I think is either chapter 8 or 9 in the textbook. And so for Thursday, I said, all right, everybody come to class, set up a virtual machine with Windows, make sure it's safe and locked down. And I gave them all instructions how to do that. We come into class and I have them all download malware onto those VMs. And I say, all right, well, we're going to do it the old fashioned way where you're actually going to run it, see what happens. We'll take notes on what happens to study it. And then we'll kind of break it down from there. And they get to the point where they have the malware downloaded. They go to double click. And of course, I forgot to tell them, disable Windows Defender. And sure enough, Windows Defender pops up on the screen. They panic. They immediately shut down the virtual machine. Some of them even destroyed the virtual machine outright. So they couldn't even get it back up and running if they wanted to. I've actually found that to be really encouraging. Right, you could see that as a failure, but you could also see that as here are honest, quote unquote, normal people who are learning a skill, who kind of did the thing a lot of people would do, right, with that reaction. And so I'm really encouraged to see that people are taking information security seriously, are taking, basic warnings seriously. And yes, I do want to move them to the point where they don't have to be afraid about running malware in a lockdown VM that won't hurt them. But right, it also is a nice teaching experience, right? Being able to walk through why we took the actions we took. And then, of course, right, I helped them along and did the things that we were going to do for that class. So those are the 3 courses that I've come up with so far. I have one course that I definitely am going to add on secure coding. Students beg me to teach a secure coding course all the time. So at some point, I will do that. Other things that I do for students. So once a month, sometime in an evening, it's usually a Wednesday evening, we do hangouts for all the information security students. We watch movies. We're going to have a panel for people who work information security as a job, come in and talk to us about what they do for a job and how to get started. I buy pizza and soda for them, right? So you end up doing a whole lot more outside the classroom as well. And then I've also been pretty aggressive in pursuing research grants. And so I have one grant which will help us make an information security hub here at RPI. And I'm going to have students help me both write the software and get the physical space up and going for that information security hub, right? And so you can help extend and augment their education through becoming mentors and becoming people who are experts in information security for the rest of the campus. I also end up having to sponsor a lot of independent studies. They're always exciting. They're always something different. I've done things from other certification exams like the OSCP to penetration testing, independent studies, you name it, I've probably done it at some point. And then for our master's and graduate students, I often sponsor all the InfoSec master's projects as well. And I have tons of interesting things that have come from that. My master's students are super smart. I wish I could get them to stay at RPI even longer, but they all want to go off and make lots of money on the job, which I can understand. I've had projects for things like how to do like currency fraud analysis for small businesses, one on redesigning SQS to be more security focused. So lots of really cool stuff going on there. So the future, like I mentioned, more courses, more students, all that good stuff. And so I want to kind of wrap up with what you can take away from all of this. So we need you to be a person who is involved with mentorship and with education in InfoSec. If you're in a workplace that does not currently do mentoring, figure out how you can do so, because we need people to do mentoring for the up and coming IT security professionals. We also just need more people willing to teach, even if that's just like an adjunct somewhere at a university or a college that's local to you or a community college. That goes a really long way. You can be taught how to teach. It's a skill, but you get better at it over time. My thinking is we're not going to be around forever. So let's make sure that the next generation builds on what we've done instead of reinventing all the wheels. And if you are an InfoSec person and you want to get your foot or feet wet in doing that, come talk to me. I always have slots open for guest lectures in my courses. And that's a good way to find out whether or not you actually like doing the whole teaching and mentoring thing. All right, and so with that, I think I'm at my 20 minutes. So thank you for listening to this quick little talk about what we're doing here at RPI for InfoSec. Happy to take any Q&A with the time we have left. Those are all the places that you can reach me, my email, social media, LinkedIn, personal homepage, all that good stuff. And with that, I will turn it back and we'll do Q&A.
Okay, thank you very much. That was really interesting. No one's popped up with any questions in chat yet. I think I can come up with a question. How do you see this meshing with, so like I get the impression this is all like industry and academic level, right?
Mm-hmm.
In what ways does that mesh with like community outreach? Like how do we teach regular people proper skills?
Yeah, so that's coming with our hub, I think. So one of the things that I'm aiming to do with that hub is be a place where companies can come to us and say, hey, we don't know a lot about information security, but we have lots of employees who need some sort of awareness. What can you do to help work with us to bring that awareness to our employees? And so kind of one of the things that I've been pretty aggressive on in designing that information security hub is getting our students to the point where they are thinking about community outreach, and then hopefully they'll be the ones actually doing that community outreach. So I'm kind of looking forward to seeing that actually come to fruition.
Okay, that's really exciting. Still no questions in chat. I think we can wrap up early if you have nothing else that you want to cover.
That's it. So like I said, if you want to come talk to me, there's all my contact info. And thank you to SeaGL once again for having me. This is my second time talking here, and it's always a great experience.
Okie dokie then. Thank you everyone for joining us. Up next in this track, we have debugging reproducible builds with Vagrant Cascadian. After that is Teagle, an announcement of the costume winners. Again, big thanks to our platinum sponsor Jump for sponsoring this track. Lacey, I see a couple people typing. Okay, no questions. Couple of thanks. Thanks from Lacey and Freette, bunch of randomly generated characters. Awesome. Okay, and we're live. Welcome back to SeaGL 2021. For this session here, we have debugging reproducible builds one at a time with Vagrant and Cascadian. And the floor is yours, Vagrant.
Hello, everyone. Can't see you. How unfortunate, but here we go. I just basically wanted to share with you all pretty much exactly how I go about debugging reproducible builds issues. And pretty much this is basically going to end up being a live demo. I've kind of pre-done some of this stuff, but hey, we're live. So one of the first things I tend to try and do when I'm doing reproducible builds work is first I try to identify, like, well, what's broken so I can fix it. This is a little different than if you're working on a specific project, because here I'm basically working on all the projects. So one of the first things I do is I go to tests.reproduciblebuilds.org, which might redirect you to CI tests. And you can see various distributions that have existing tests available. I'm going to be focusing on Debian because it's what I'm most familiar with. But this page shows boatloads of packages in Debian, in the ballpark of 30,000 packages being tested, many of which are reproducible. But when you're dealing with that many packages, I like to narrow it down a bit. So, oh dear. So here in the unstable distribution of Debian, we have roughly 4,000 packages that fail to build reproducibly and 1,400 packages that fail to build at all. So I would like to narrow those numbers down a bit. So one thing I can do is I can focus on the testing distribution in Debian, which is currently the Bookworm release. That narrows it down considerably, but it's still a lot of packages. So there are a few different ways you can pare it down. There's the without notes package sets. So those are packages that haven't really been troubleshot before. So they have various different... you can go and look at one of them, like HSail tools, happened to be the first one. And here, there's the differences. So basically, what this infrastructure does is it'll build a package, and then it'll change a bunch of things in the environment, but not anything that should affect the build. And then it will build it again, and then compare the two packages with a useful tool known as diffoscope. And this is basically some diffoscope output. You'll notice for unstable, there's it's about 98.3 kilobytes of diff. And let's see, for bullseye, we get 154 kilobytes of diff. That's exciting. It's a larger diff in the testing distribution, which actually varies fewer things, which is a little unusual. So I have a build here where I've done a build of HSail tools using one of my favorite tools, and that is ReproTest. I tried because it wasn't immediately obvious from the diff like what kind of issue it was. It's just a whole bunch of gibberish in build IDs, debug IDs. There's something embedded in there that's changing the resulting binary. Because of that, I decided to run ReproTest with the auto build mode, which is really cool. It will go through and vary one thing at a time systematically. Unfortunately, it tries to do two builds in a very normalized environment, and if it still can't come up with reproducibility, it can't tell you whether it was a timestamp issue or the build path or the username or anything like that. So unfortunately, this package seems to be, for the moment and the scope of this talk, a dead end. But another package I had actually worked on just a few days ago, Minia. Here we have the diffoscope output, and here we'll see in unstable, The diff is roughly 148 kilobytes. And we're looking for any difference that kind of seems human readable. And you'll notice here it's embedding the kernel version. So that's one that I have some experience actually debugging. I like to kind of scroll through the rest of the diff to try and identify other issues. But the last I looked, that might be the only issue here. So, I've got, what I did basically was dgit clone minia. And that's kind of I don't know if you've ever tried to package packages in Debian before. It's a little bit ad hoc what the environment's going to be like. It might be in various different revision control systems. So I like to use dgit because basically it puts everything into Git. So I did a build of this not too long ago. Let's see here. And I was able to reproduce the problem that was shown on test.reproduciblebuilds.org. All right. And Linux. Let's see here. There we go. So I was able to reproduce the problem. It kind of does this crazy, reprotest does this crazy trick to emulate and basically lie. It tricks uname into reporting the wrong kernel version. So frequently, packages will use uname to embed like uname m or something like that, uname or uname a or uname r. Uname r is pretty common here, but you'll notice if you run a build on one machine and then you upgrade the kernel to a different version, that's just always going to come out with a different build if it's embedding the kernel version. So I like to grep for uname as one of my first attempts, but that just doesn't show up anything. So then look at the source of the repository and I see CMake lists. And CMake lists, CMake's lists kind of tells me it's CMake based. Probably, maybe. And I know in CMake, there's this feature where it basically does a uname-like thing. So, into the binary. All right, so what I'm going to do is strip that out. And then we're going to run a build. So instead, you can use CMake system, which just reports the operating system. I believe, like in this case, it would probably output Linux instead of Linux 5.14.0, blah, blah, blah. So now, all right, now I'm going to rerun the build with this package. And I'll have to come up with something else to do. But I think this build should go pretty fast. So we've got that running in the background. We'll come back to that in a couple minutes. So some other packages we might want to explore. Another whole strategy I use is package sets. So I'm trying to narrow it down from 4,000 some packages to evaluate down to a small number of packages. So in this case, in the essential set, we only have one package left in Debian that's not building reproducibly in Bookworm. And there's a patch for it, and it says it's done. So let's take a look at Perl. It looks like a newer version of Perl in experimental is actually reproducible. That's probably where the patch was applied. So someday, when we see a newer version of Perl land in Debian, that will probably build successfully reproducibly, we hope. So I'm probably not going to focus too much on Perl since it looks like the fix is already in progress. In the required set, we've got a few kind of important packages, GCC and apt. I've poked at those before. I would love it if somebody else takes a look at them again. GCC does this thing where they embed test suite logs in the actual packages. We'd like to get that fixed. It's a valid use case, but I don't know what we're really going to do right now. Certainly not in the remainder of this talk. And apps similarly has complicated build issues I've never quite sorted out. So let's go back and look at some other package sets. Build Essential, these are all the packages that can be assumed to be installed when you're building a Debian package. Still, GCC is back in there. BinUtils has the same embedded log file kind of build problems. Perl's already theoretically fixed. And Linux has a bunch of documentation differences, I think. That's probably going to be fixed at Sphinx. Last I recall, it just randomly throws a bunch of files around. So I've tried this one before. I'm not going to fight with it just now. But as you can see, the package sets are getting larger and larger. So the build essential depends. So these are all of the things that you need in order to build all of the build essential stuff. And I've been focusing a lot on this package set. You can see a lot of these pluses represent patches and the Ps represent things that are pending. So hopefully they'll land soon. Other people have been working on this too, but I really did a lot of focus on this package set recently. So that narrows it down a lot. There are unfortunately packages that fail to build from source at all, which in the course of a 20-minute talk are way too much to get into. But let's check back in on how that build is going. Oh dear, that didn't fix it at all. So we still have a diff. I remember the issue here. Okay. So I think what the issue here is the build path is still getting embedded in the file. So I'm going to run another build with the build path removed, and I'm going to hope that will fix it. All right, so it looks like we've got another 2.5 minutes to go to come up with other things interesting going on. So in the package sets, you've got all of these various key packages in Debian. Yeah, that one, I've also done a little bit of work on this, and other people have too. So that one's looking not too bad. As you'll notice, our reproducibility numbers for a lot of these sets are around 90-some% or more. Which is pretty exciting. There's also some packages based on maintenance teams. So there's like the Perl package set, various language specific ones, Java, Perl, Ruby. Those are interesting. I recently added this to the list and it looks like it's fully reproducible. So the mobile maintainers package set is looking great. And another distribution package set is the GNOME package set, which is looking not too bad, mostly reproducible. There's a few left, and many of those have patches already submitted. So I'm not going to focus on those today either. I just wanted to show you. Let's see how KDE is doing by comparison. A little less good, but not terrible. So one of the big differences, if you look at these same package sets in Unstable, is you'll see a lot more failures typically. And that's because we actually vary more things in the build environment, most notably the build paths. So that's pretty exciting stuff to get into. Normally, I like to focus on just the testing distribution, which doesn't vary build path. Because I like to narrow it down to a smaller set of things to focus on. And then if I happen to figure out how to fix the build path, I'll do it. Looks like we may be on the verge of a successful build. Let's see, HSail is still waiting. So let's see, we did that one. I filed a bunch of reproducible builds patches on GCC ARM None EABI, and I like to review like, oh, how did all my patches work? My build environment is not exactly the same as what test.reproduciblebuilds.org uses. So I like to go back and review. And in unstable, apparently the diff is so large that it fails to even diff the output, which is unfortunate, but in testing, otherwise known currently as Bookworm, it's got a diff, and it's a fairly large diff, but it's a fairly small difference. So it ships a source tarball, and see here, Diffoscope basically goes through and it identifies, oh, this package in your build wasn't reproducible. Here's your package. It's a little bit different in size. And here it's a little bit different in size. So it's extracting the contents of that package and expanding it out into control.tar.xz. And then it's like, okay, xz, I'll uncompress that. Oh, I've got a tarball. It uncompresses that. And inside of the tarball, well, Debian, its tarballs all the way down, I guess. So inside the data, there's actually a single file that's not reproducible, and it's yet another tarball. What did I say about tarballs all the way down? And in that package, you'll notice there aren't a lot of differences. It's only the file permissions in each of these files that differs. The timestamps are the same. Just about everything's the same. So my patch was mostly effective earlier, but I missed some things in the tarball. I think this build takes a little too long to actually get into. Yeah, it's not a particularly fast build. So this is the previous test history, and I use that just to gauge, oh, how long do I have to work on this, and is this a reasonable one for me to work on? Right now, I would say no, it's not quite a reasonable thing to work on.
And that's our 20 minutes.
Oh my.
Yeah, time flies.
And it still didn't build successfully, even when I did no build path. All right.
First off, we have mad props. AJ says mad props for mad respect for the entire thing being a live demo. So,
excellent.
Yeah, AJ also asked any insight into what caused the drops or spikes in reproducibility in the graphs.
Oh, there are a few different things. Let's see here. Do we have any immediate one? So I think in this one, you'll notice there's a spike. I don't know if that shows very well. So here, obviously, this is when the project started. And so there's a big spike just from testing it. Here, we actually started varying build paths. And so a bunch of things stopped becoming reproducible, and gradually that rose up again. And then some of these things are, gradually you'll see the curve go up. But relatively recently, in the last few months, we had a release. And so now, it kind of stabilized for a while because they weren't really uploading a lot of packages in preparation for the release. And then it kind of dropped down again because people started uploading lots of things to Debian and things started breaking. So the thing about reproducible builds is it's a constant effort. So new packages can introduce bugs that were previously fixed, or new kinds of bugs that we've never seen before. So it's a constant vigilance process.
Gotcha.
Hope that answers your question. And sometimes they're just weird flukes, the weird flukes in the spike,
Right. Somewhat off topic, it was brought up. B asks, why would you embed test logs in the executable?
So they embed the test logs because they need a place to get. It's not in the executable per se, but it's in the .deb package. We don't have a good mechanism in Debian at the moment for shipping things where it's like you might want the test logs to be able to see, oh, I made a change to the I patched something. I changed something and I wanted to see, like, well, how are the test logs building faster? Is it introducing any other weird issues? Like timing issues is like, I think they're mostly with GCC. It wants to see if the speed improvements improved or slowed down or were tolerable slowdown, that kind of thing. So I can see a valid use case for having that data somewhere. I would like to figure out a way how to not ship it in the .deb package that people actually install on their machines, and we don't have a good mechanism for that just yet. Though we're kicking around some ideas how to fix that problem, because it really would be nice to get our core packages like GCC reproducible.
Okay. One last question, also from AJ. AJ said they saw apt in the GNOME set for a dependency. Is that just a transitive dependency?
Could be. It might actually. I mean, there might be some GNOME utility that uses apt. I'm just speculating it here. It's a little outside of the scope of reproducible, and it could just be a bug in our data. Our data is not necessarily perfect. It's usually a best effort kind of. This package set represents this suite of software. So, I'm speculating here, but yeah.
Gotcha. That's all the questions that have popped up. Penglish says, time flies, but your computer builds really quickly.
Cool. All right. Well, thanks, everyone. Sorry I didn't have more details, and really sorry I didn't manage to get that one building reproducibly. Anyway.
Makes for a unique talk, right?
Yeah. Excellent. So yeah, I won't be reproducing this talk ever again. But I might do another talk kind of like it. So anyway, thanks everyone.
Gotcha. Yep. Thanks for joining us Thanks for joining us at SeaGL 2021. Up next in the social room, there is the announcement of the costume contest winners, and Teagle is also upcoming. Thanks again to our platinum sponsor Jump for sponsoring this track for today. Have a great time at the rest of SeaGL, everyone. Welcome to our final talk for SeaGL 2021 before the closing keynote. This talk is Katie McLaughlin's Expressive Security, Vulnerabilities with Emoji. This is a pre-recorded talk. Katie is in the chat, so if you have any questions at any point, type them in there and she'll be there to answer them. And here we go.
Hi, I'm Katie. I do a great number of things on the internet, but when I'm not changing the world, I like making tapestries, cooking, and seeing just how well various application stacks handle emoji because, gosh, it's a lot. This is Expressive Security Vulnerabilities with Emoji. Except it's not. It was supposed to be Expressive Security Vulnerabilities with Emoji Closed Lock with Key. But the CFP system for SeaGL sort of exploded when I tried to submit that talk. The fork of the open source event manager OSEM system that SeaGL uses gave me a lovely 500 error trying to submit this talk. But it's okay, it's not just y'all, this happens everywhere. But first, let me go back a bit. TLDR, because computers, we have this thing called Unicode. And Unicode gives us a huge address space to encode over 1 million characters to allow every character of nearly every written human language to be encoded within it. But as this standard grew, more than just alphabets were added. The very early versions of Unicode had all 3 of the main writing systems used in Japan, that is, hiragana, katakana, and kanji, but not their unofficial 4th set. Originally implemented in different ways by different telcos in the 90s, the space left in the in-character encoding systems for Japanese mobile phones were used to store some really cute little pictures. And these symbols were very popular, but were often implemented differently between different phone vendors. This was standardized in 2007 by putting them all into Unicode. And then nothing happened until the iPhone came along. To enter the Japanese market in 2010, Apple had to support emoji. And so, it was implemented, but specifically for the Japanese market. Eventually, this feature flag ended up on iPhones in the US, and story goes, one day somebody found this feature hiding in a custom setting in a third-party app and went, huh, I can send a pile of poop to my friends. And thus the Precambrian explosion of emoji started. Every year we get more and more emoji, addressing memes and frequently requested emoji, and addressing backwards compatibility, like the cowboy emoji. This emoji was added to Unicode because it was an emoticon in Yahoo Messenger. We start getting communities putting together proposals and designs like the fortune cookie. Every year even more emoji are added, as they are approved by the Emoji Subcommittee of the Unicode Consortium. This submission process is open to the public, which means that any whoever can suggest an emoji, and if the submission is strong enough, might just get accepted. Like me. The parrot was me. Sorry. We start getting even more inclusive and diverse emoji, like the representation of bionics, and more diverse food and animals. And yet, this set still isn't complete, as we are getting things we've been missing for a long time, like the single coin emoji. Again, me. Sorry. The list for 2021 has been announced, but the images won't be available on your devices until probably early 2022. The images displayed here are sample implementations, but different vendors, Apple for iOS, Google for Android, Microsoft for Windows, etc., are completely free to choose any interpretation they want, which becomes an issue when these different implementations don't match. Let me show you an example. Sadly, the seagull emoji isn't an emoji yet, but the parrot is. These are all the code.1F99C parrot, but depending on your platform, you're seeing either a scarlet macaw or anything from a Carolina parakeet to possibly a black-winged lovebird to an eclectus parrot or even a sun parakeet. While these are all parrots, they're all the wrong parrot. None of them look like Sirocco the kakapo, for which my original parrot emoji submission was based. You might also recognize him as the party parrot. Party all the time. Emoji implementers are under no obligation to use the suggested designs in the submission documents, so you end up with all these variants. But it's not just issues between platforms. The issues can also occur on the same platform between different code points. The landmark case of this is between these two emoji, the beaming face with smiling eyes and the grimacing face, subject of 2016 paper, Blissfully Happy or Ready to Fight, Varying Interpretations of Emoji, from the University of Minnesota. Before 2015 on iPhones, the only difference between these two emoji were the eyes. In the West, we might look to the mouth to work out where emotion is, but particularly in manga, the eyes are used to express emotion. In 2016, the beaming face with smiling eyes emoji was updated to also have a smiling mouth, thus eliminating all misinterpretations of emoji forever. As the years go on, the emoji representations that single vendors use can also be updated. The Apple emoji from 10 years ago look similar to the emoji today, but are much more detailed. For example, the pig is now smiling. Suffice to say, I am an enormous emoji nerd. I have multiple emoji in the Unicode standard, and I've been published in multiple articles about emoji. This is all because 5 years ago I started giving talks on the subject. Since 2016, I've given this talk, The Power and Responsibility of Unicode Adoption. Except that's not the talk title. This is the talk title. The Power, Lightning Bolt, and Responsibility, Faced with Cold Sweat, of Unicode Adoption Sparkles. And the very first time I gave this talk, I had problems. The first acceptance email for this presentation had the title of the talk just truncated. Congratulations, your talk has been accepted. Selected talk, The Power, Lightning Bolt, and Responsibility. Huh. Some systems won't let me enter the talk title in the first place, but will tell me that the problem will soon be solved. I should hope it's been solved, as EasyChair was the CFP system for the 4th International Workshop on Emoji Understanding and Applications in Social Media, held earlier this year. Some conferences get it right in some places, but wrong in others. The next few examples are all from the same event. For this conference, the title displays correctly on the website schedule, but the printed schedule, there's just an empty void. And on the AV run sheet, there were giant black boxes everywhere. You'll also note the check title handwritten note there. The session chair for this talk had yet a different printout, which she, with consent, repeated verbatim. So I was introduced at this event as speaking about the Power, Lightning Bolt, and Responsibility Square of Unicode Adoption Square. But even better was the digital display signage in the conference center outside the room I held my talk in. It worked, mostly. You can see that the emoji are there, but this is where the segue into the security part of the talk begins. I can tell you by looking at this picture alone that this conference center was running Windows 8.0, and I can tell just because of the emoji. This is the face with cold sweat emoji as represented on Windows 8.0. For code points on systems that get updated often, using the knowledge about when vendors were specifically making these tiny tweaks to their emoji, you can pin down to the minor version the operating system that's running. The next version of this emoji may or may not appear flat or 3D shaded, depending on which variant ends up being available in the retail version of Windows. You can use this information to possibly tell who's still running a preview in the future. This of course all presumes that you're running the base operating system with no customizations. Especially if you're running Linux, you may have already experienced an issue with the lack of richness of your emoji, and there are various ways that you can install custom fonts and extensions to adjust this. But it's not just humans that misunderstand emoji. Computers are especially terrible with certain Unicode characters. This is the pride emoji. Though it's technically not its own emoji, it's a combination of various emoji. It's the combination of the blank flag emoji, a rainbow emoji, and between the two, a special character called a zero-width joiner. Allegedly, this is pronounced zwidge, The zwidge is also the hidden code point that allows you to use skin tone modifiers on various hand and face emoji. When this functionality was added to emoji back in 2016, it caused some fun. For instance, if instead of this sequence, you sent this sequence, flag digit 0 rainbow, to your mate with an iPhone, it would just crash. This isn't the first time, and it won't be the last time, the unique sequences of characters cause mobile devices to just nope. You can hide a lot of non-displayable characters in a message that a copy-paste allows to be shared by various mobile users, and the phone will just reject it. And it's not just emoji. Combinatorics of scripts like Arabic and Telugu have been reported to cause such issues as well. These are just some of the examples of combinations that have rebooted enough phones to get news coverage. But the biggest example of all these issues coming together happened a few years ago now, and it's a super interesting story. The link on the screen goes to a great write-up of the issue, including a link to the original LoopConf recording from a lead developer of WordPress, and a post from the original vulnerability identifier. This is all about CVE 2015-3438. This isn't a problem specific to WordPress, but given it did happen to WordPress, and WordPress powers a significant percentage of websites on the internet, it's not too outlandish to have in my abstract. We'll also cover how one WordPress fix saved a quarter of the internet from cross-site scripting attacks through emoji. The WordPress 4.2 blog post announced that this release features extended character support, noting emoji are now available in WordPress. Back in 2015, this was a huge deal. You could use emoji in WordPress if you just update your installation. Our users will really like that. Let's go do it. Install updates and get new emoji is actually a really engaging model for making people do updates. Update and get new emoji. You'll also get many security improvements and critical fixes, but you'll also get new emoji. Versions prior to this, though, with particular database setups, were susceptible to cross-site scripting attacks using just emoji as the vector. And I'm going to show you how this works with a smile. Specifically, this smile. This is not your average smile. This is code point 1F642, and it's the slightly smiling face. It was introduced to Unicode 7.0 back in 2014, and it will work for our purposes. What won't work is other smiling faces. This face won't work. It looks far too kind of hard to participate in such mad hacks. This is the white smiling face, emoji style. That FE0F at the end is the variant selector 16 character, which when appended to a code point that predates emoji asks the system to render it as an emoji if possible. If you don't specify this, you get the text version of the emoji. Another fun fact, if you've ever received an email with a random capital J at the end of a sentence, that's from somebody sending you an email in Microsoft Office using the Wingdings font, which has the smiley face in the capital J code point. I will also note that this is the white smiling face as opposed to the black smiling face. They're called white and black in the Unicode standard, where it's more of a unfilled versus filled. Back to this smiling face. This code point starts with a 1F and has 5 different characters to denote it in this encoding, as opposed to the other smiles which had 4 characters. The encoding here makes it look like we're just using 1 byte, but if we expand it out, it's actually a multi-byte character. This is the critical part of getting this hack to work. Let me show you with an apocryphal example. Here is a blog. You've just read a very nice blog post and now you're going to engage with it positively, like a nice person. And so you type up your comment. It's such a happy comment. You're engaging with the author, providing positive feedback to their work, all good. But if the setup allows, you'll end up just getting this posted. This is such a great post, but where's the rest of the comment that was entered? Gosh, better go back and add that again. Here we go, let's make sure that I get that quotation from the original author in there. And posted. Great. But if we mouse over this page, we've successfully injected JavaScript into the application. Let's look at what went wrong here. This is a section of what the rendered page would look like. You'll note the copious amount of green text that isn't being highlighted, and you'll also note the lack of the smiling face we originally entered. A lot of websites will have data validation that will disallow script tags and other such things. But we can get around this by submitting our data in multiple comments. In this example, we're also taking advantage of the use of different quotation marks to effectively escape out a bunch of HTML. And the biggest part of this is the truncation of our content. This is where the emoji comes in. What should have been an insert into the table with our entire first comment ended up being truncated the first time that a multi-byte value is hit. This is a behavior of MySQL if you don't have strict mode enabled, and if you're using an encoding system that doesn't support multi-byte characters. MySQL will just give up when it gets to a strange code point. And so this cascades all the way back, so you can insert multiple comments that include carefully crafted script tags and other such nonsense that would bypass conventional filters for a literal open bracket script close bracket tag. If you're using MySQL, make sure you're using the UTF-8 MB4 character set, which supports 4-byte UTF-8 encoding, and you'll avoid this issue. Also set strict all tables to make MySQL error if it gets any sort of bad values where the data requested to be inserted doesn't match the actual data inserted. There are already several bugs in both the SeaGL fork and the original OSEM software from other speakers reporting issues submitting emoji in their talks. If you're a Rails dev, maybe give this bug a go. There's advice linked in there about how you update the encoding of specific fields in Rails 5, and it would be super useful to be able to use emoji in this system. Also, if you are interested in inspecting what emoji are being used in various strings, if you gem install Uniscribe, it's an app that I use all the time to work out the names and code points for a bunch of emoji. Regardless of what system you're using, try adding the odd emoji into it. Adding a single emoji and confirming it's correctly written to and displayed back from a system can confirm an entire pipeline of Unicode conformance that, in theory, also means that your system will support all the other parts of Unicode, like the parts that your users might have if they use written character sets outside of the basic Latin alphabet. And that's all I had today. Thank you so much for watching. All the resources for today's presentation, including the slides, are available at glasnt.com/talks, and I'm always happy to talk about emoji with anyone. Have a great rest of your day.
Okay, that is the end of our talk. We still have 10 minutes left for Q&A. Katie McLaughlin, as a reminder, is in the chat. You can pop in any questions, and she is there to respond. That is our last talk of the day. Our next keynote is Cory Doctorow at misplaced. And don't forget, after the keynote at 5:30, we have tea sandwiches with Molly and Sri. 6:45 is SeaGL Trivia. Thanks for coming to SeaGL, everyone.
All right. Well, thank you all for another fantastic SeaGL. Our second virtual SeaGL, I think, has been a flying success, and I absolutely could not have occurred without all of you. Now, before we get started with our closing keynote by Cory Doctorow, I do have a few thank yous and announcements that I have to make. First off, again, a big thank you to all of the attendees, speakers, and volunteers. You make this event. You make it what it is, and you make it worth doing. And a special thanks to this year's all-volunteer SeaGL staff who've been working tirelessly behind the scenes to make our second all-virtual conference a reality. I'm Salt. I'm this year's impresario, and in charge of our other committees, we have Rachel and Nathan, who brought you the programming and flow. Deb and Monica for the attendee experience. Lacey and Dorian were behind our volunteer efforts. Ben and Mateus led promotion and outreach. Shri and Hans were behind partnerships. Hans and Norm were behind finance. Syntaxer and Keith behind our technical team, with a special shout out to Andrew for the many, many last minute matrix and website customizations. And Rachel and Lacey, thank you for keeping the conference safe and heading the Code of Conduct Committee. I'd also like to thank our platinum sponsors, JMP Chat and Amazon Web Services. Our gold sponsors, Schedules Direct, CSATs, part of J&J, Google, and the Ubuntu Community Fund, as well as all of our other SeaGL 2021 sponsors, which can be found, of course, online and throughout the event. Now, on to some announcements. First off, to alleviate any concerns, all sessions have been recorded and will be available on the Internet Archive shortly after the conference. This year, we've been trying to do a lot of things to figure out how to bring that fun SeaGL spirit online. Hopefully, many of you have seen that we have sticker packs that are available for Matrix, Signal, and Telegram. There's a blog post about that and links on the website. We've also been soliciting suggestions in terms of our SeaGL color palette. As you can see, we have a bunch of ongoing things that have been kind of keeping on theme now for 9 years. Well, the votes have been tallied. The results are in, and the SeaGL color names are Tidal Blue, Puget Sound, Deep Ocean, French Fry Gold, Wet Sand, Brave Goal, Gloomy Sky, Stormy Sky, Storm Cloud, Penguin Black, Bread for Screaming At, and Eggshell. All of these will be on display alongside the actual color details in a future blog post. Now, in addition to our usual speaker, sponsor, and volunteer gifts, we have a special treat to announce. Thanks to the support of the Ubuntu Community Fund, Mind's Eye Creative has been preparing graphical recordings of each session. These illustrations we shared out shortly after the conference. And as a reminder, we'd love to hear from you. We're currently collecting feedback via seagull.org/feedback, and good, bad, suggestions, comments, we'll take it all and read it all because we really care and want to keep making this a better event. Another reminder, we have a short break after the keynote. Then there will be a couple of social events during our post-SeaGL party. From 5:30 to 6:30, you can join Molly and Shri in making tea sandwiches. And from 6:30 to 8, Remy and Alana will be running trivia. Come win some prizes. Each of these events are listed in the Pacific time zone, and these will be held in our social room on Matrix, which can be found, of course, by visiting attend.seagull.org. Now, last but absolutely not least, as you know, next year is the 10th year of SeaGL. So, for the first time ever, we've decided to select and announce our date a whole year ahead. Please mark down November 4th and 5th for SeaGL 2022. Now on to our final keynote and presentation of the year. Cory Doctorow at craphound.com is a science fiction author, activist, and journalist. He is the author of many books, most recently Radicalized and Walk Away. Science fiction for adults. How to Destroy Surveillance Capitalism, a non-fiction about monopoly and conspiracy. In Real Life, a graphic novel, and the picture book, Posey the Monster Slayer. His latest book is Attack Surface, a standalone author adult sequel to Little Brother. His next nonfiction book is The Shakedown with Rebecca Giblin, about monopoly and fairness in the creative arts labor market. In 2020, he was inducted into the Canadian Science Fiction and Fantasy Hall of Fame. And SeaGL is so excited to have him keynoting our event. So without further ado, I present Cory Doctorow.
Hi, I'm Cory Doctorow, and I want to start by maybe busting a myth. This myth that in the 1990s there were a bunch of blind techno-optimists who thought that if we could just connect everyone to the internet, everything would be fine. That's a charge that's often leveled against people like me who were around back then as young technologists, and even more importantly, at the kinds of people who were involved in starting organizations like Electronic Frontier Foundation, the group that I've worked with now for a good 20 years. I joined it about 10 years into its history. And the thing is, it is a myth because I know those people, and they didn't start the Electronic Frontier Foundation because they were sure everything would be fine. The reason you start an organization like the Electronic Frontier Foundation to defend human rights in the digital world is not just because you're very excited about what could happen and how well it could go, but also because you're starkly terrified of how badly it could go. Your motto isn't, "This is all going to be so great." It's, "This could be so great if we don't screw it up." Now, before technology came along as a source of regular stock bubbles, it was a passion that people pursued. Programmers made stuff happen. If you sat down at the keyboard of your early personal computer and figured out how to precisely input a program that would crisply reflect your will, what you wanted it to do, you could have the computer infinitely reproduce your will on your desktop forever at effectively no marginal cost. It was a heady feeling. And then there was the even headier feeling of what happened when we got modems. We were able to project our will around the world. We were able to give other people the ability to reproduce our programs on their desktops. It's a bit like sharing a recipe, like maybe your grandmother's beloved brownie recipe. But if the recipe, when it got to your friend's house, would actually walk into the kitchen and prepare brownies for as long as they wanted, exactly as you had intended them to be prepared. And that feeling, that headiness, that rush, it's the rush of self-determination, of deciding how you want to live your life and then getting to live your life that way. And the first conflicts that we had in technology were conflicts about self-determination, like the origin of the free software movement. Very famously, a young AI researcher, Richard Stallman, needed to print some documents at MIT, and the printer drivers weren't working the way that he wanted them to, and so he went to the drawer where the tapes were kept so that he could fix the printer driver. And the door had a lock on it, and he was told by the people responsible for the lab that from now on, you either use the printer drivers you're given or you go somewhere else. But what you don't get to do is decide how those printer drivers work. That's the origin of the free software movement. And likewise, not many years later, a young software developer named Bill Gates, who was part of this thing called the Homebrew Computer Club, sent a letter to his colleagues saying, "I know that the way that we do programming, the way that we do computer science is with knowledge sharing, that when I write a program, you hack on it, and then I hack on it, and then that person over there hacks on it. We all see who can make it better. But those days are over. From now on, I'm going to write programs, and you're going to run them, but you're not going to change them." Now, those fights over self-determination set the tone for the next 40 years. And some of the worst nightmares of those early digital rights pioneers have come to pass. Like, we did get the total penetration of technology, software and eating the world, microchips and everything. But at the same time, all of those systems, all of that software, all that hardware is configured and designed to have centralized control, to exercise continuous surveillance, to manipulate the people who use that technology so that they will conduct their lives according to the priorities of the shareholders of the company that made that technology, not according to their own priorities. That self-determination takes a back seat to the priorities of the shareholders of the companies that make the tools that we use. Now, how were we dealt such a stinging defeat? How was it that we planned for something so great and that we took steps to try and safeguard it, and yet we lost so badly? What did we miss? Well, we didn't miss the possibility that we would end up in a dystopian future. That was very much alive in everyone's imagination. I mean, this was the dawn of cyberpunk fiction after all. The thing that we missed, the thing that we didn't anticipate, was monopolism. Now, that early internet, that early technology world was very dynamic, and that was thanks in large part to antitrust law. So in 1982, the year we got a modem and I started to dial up bulletin board systems from my home in Toronto, that was the year that AT&T was broken up by the US Department of Justice. And that breakup had a number of salutary effects, but one of the biggest ones was to make it a lot easier to use and run a modem and to make long distance calls. And all of a sudden there were BBSs everywhere. And in Canada, where we didn't even have AT&T, we benefited because that BBS software made its way north of the border. And then in 1984, a big company called IBM that I'd had very little to do with as a kid suddenly was on the scene with computers like the ones I was using, the IBM PC. But strangely enough, the IBM PC, it didn't have an operating system from IBM. It had an operating system that was made by a new company, a startup called Microsoft, or as it was called back then, Micro-Soft, started by a couple of young hackers, Bill Gates, the guy who wrote that letter to the Homebrew Computer Club, and his pal Paul Allen. And the reason that IBM didn't make an operating system for its PCs is not that it couldn't. IBM had made operating systems for a long time. In fact, that was why the Department of Justice had spent 12 years dragging them through antitrust hell. Because for the 12 years before the PC came out, IBM had been sued by the US Department of Justice for monopolism. And every year of that lawsuit, IBM spent more on antitrust lawyers than the whole US Department of Justice. And that was the only reason they won. And I say won, but I'm going to put it in quotes here, because after 12 years of outspending the entire US Department of Justice and being dragged up and down the road by the US Department of Justice, the IBM did not want to be the IBM of old, the IBM before the antitrust inquiry. They wanted to be a new IBM, one that wouldn't be in the DOJ's sights. And they knew that the DOJ was really angry about IBM tying its operating system and software to its hardware. So they said, we're just not going to make our own operating system. We'll get these kids to make it for us, these Microsoft kids. And so all of a sudden there were PCs all over the place. And not just IBM PCs, because this other thing happened at the same time. Which was that software and hardware hackers working for Phoenix, a little tech startup, reverse engineered the IBM ROM. That was the thing that turned commodity hardware into an IBM PC. And they made a compatible ROM that would let anyone buy the chip from them and then make a PC. And all of a sudden, there weren't just IBM PCs. There were IBM PC compatibles. There were Dells and Compaqs and gateways. And again, IBM didn't want to crush these companies, although they could have. They'd had a long history of crushing hardware companies that competed with them. That is, in fact, one of the reasons the DOJ got so angry at them. And they understood that if they were to go back to those tactics, that they would end up back in the DOJ's crosshairs. And so we got this diverse ecosystem of PCs running an operating system that was independent of the hardware. And so Microsoft eventually turned into IBM. Every pirate wants to be an admiral. By 1992, Microsoft was the kind of monopolist that IBM had been. And so the DOJ dragged them back into court. And although Microsoft's 7-year antitrust hell did not result in the breakup of Microsoft any more than the 12-year antitrust hell for IBM resulted in the breakup of IBM, it did change the culture of the company. They had been accustomed to finding new tech startups like a little company called Netscape that everyone was very excited about and just pulling every dirty trick in the book to crush them. But when a couple of Stanford grad students named Larry and Sergey decided to start a company called Google, Microsoft didn't go after them the way they'd gone after excuse me, I just blew my buffer. The way they'd gone after Netscape. And that was how we got this company, Google. And so one day there was Alta Vista, and the next day there was Google, and no one was doing unto Google what they had done unto Netscape. And it looked like every day we could see a new kind of marketplace emerging. Every day the companies that had once dominated the industry could be toppled by new companies that were started by the proverbial 2 hackers in a garage. And it was in fact happening all along. And what ended it was not the maturity of the market, and it wasn't the maturity of the hardware. It was a change in antitrust. We went from this moment where it seemed like we had found a perfect kind of technology arrangement, where you could start a new company, a new software or hardware company with very little capital, that you could access a whole world of potential users and customers, and that they could switch from the old thing to the new thing at a very low cost without having to leave behind their old software, their old files, whatever, because you could just write compatibility layers or importers that would bring it along. And that meant that the best ideas could turn into companies and find customers and change the world. And here's what we didn't know, was that the breakup of AT&T in 1982, that was the last significant victory of US antitrust enforcers. Not because they forgot how to enforce antitrust, but because they were prohibited from enforcing antitrust. That Ronald Reagan and his antitrust advisors shot antitrust in the guts, and it just bled out over like the next decade, trying with decreasing success to go after tech monopolists. And that Microsoft was the last time it would even really try, more or less until today. Now, how did that happen? Well, there was this guy named Robert Bork. You probably don't know his name. If you do, if you hang out in political circles, you probably know him because Reagan tried to put him on the Supreme Court, and he was denied a seat on the Supreme Court. And the reason he was denied a seat on the Supreme Court is he'd been Solicitor General to President Richard Nixon, a guy who resigned in disgrace after committing a string of horrific crimes, which Robert Bork was absolutely complicit in. And so, back in those days, that was the kind of thing that disqualified you from sitting on the Supreme Court. But Robert Bork did far more harm to the country as an advisor than he would have done as a Supreme Court justice, because he conceived of this new way of thinking about antitrust. He wrote a very influential book called The Antitrust Paradox. And it articulated a theory of antitrust that said, from now on, we are going to enforce antitrust only when we can show that a monopoly isn't efficient. What he meant by an inefficient monopoly is one that made prices go up. And so if you couldn't prove that a monopoly, that a merger or a company that had grown through some other means or that was doing something anti-competitive, if you couldn't prove that that was all leading to higher prices, the antitrust enforcers didn't want to hear from you. And according to Bork, there was only one way to prove it. You had to prove it with these mathematical models, because otherwise, how would you know, right? One company buys another company, the prices go up. Maybe the prices went up because electricity got more expensive, or labor became more expensive, or other inputs became more expensive. Maybe like the moon is in Venus. Maybe they were losing money before and now they've decided they're going to make money. How could you prove that the monopoly is why prices went up? Well, you had to build these mathematical models. Now, astoundingly enough, only Robert Bork and his friends in the economics department of the University of Chicago knew how to make these mathematical models. And it will absolutely shock you to learn that if you paid these guys to make a mathematical model to evaluate whether or not the Department of Justice or the FTC should let you buy your major competitor, that they would say, yeah, it's fine every time. The model would always prove that it was fine. We went from a kind of antitrust that was grounded in what they used to call harmful dominance, which is the idea of an antitrust where you ask not whether there's a consumer welfare harm or prices are going up, but whether there's any kind of harm and whether that harm is the result of dominance, which means that, you know, if you live in a neighborhood with a big company that pollutes, and every time the city tries to stop them from polluting, they throw a lot of money into the municipal race, you could show up and testify at that antitrust hearing and say, look, I'm not a customer of this company, I'm not a supplier of this company, but I live next to the factory and my kids are all sick because of this company, and we can't get anything done because of their harmful dominance, right? That was a kind of antitrust that everybody could play because you were asking about the effect on people's lives, to an antitrust that was determined solely by mathematical models that a tiny group of people knew how to make and interpret. And so it was as if the king had decided to get rid of hearing petitions from the peasants who lived on the land, and instead to just have a court sorcerer who would tell him whether or not some plan by a lord or another was a good one. And so whenever a lord wanted to do something, or whenever the king wanted to do something, they would call this court sorcerer. The court sorcerer would like grab a goat and he'd drag it into the king's court, and he'd cut its throat, and then he'd slit open its belly, and then he'd spread its guts out on the floor, and he would peer at the guts and stroke his chin. And he would say, whatever it is the person who paid me to kill this goat wants to do is absolutely what the gods favor. And if someone, some courtier, some peasant, had the gall to show up and look in the goat's guts and say, I don't see that there, the court sorcerer would go, look who thinks he knows how to read a goat's guts. Did you go to the University of Chicago? So the consumer welfare theory eventually meant, and obviously was going to mean, that there was nothing we could do to stop monopolies, that if we adopted it, monopolies would be allowed to thrive almost without limit and almost without any enforcement. That basically we'd be shutting down antitrust enforcement in America. And those theories, nevertheless, were very popular. And the people they were popular with were very rich people, because very rich people understood that if they were allowed to have the companies that made the money merge with one another so they didn't have to compete with one another, then they could get together and put the screws to their suppliers, right? So they could demand lower wages from their workers, or they could demand cheaper prices from their suppliers, and that they could pocket the difference and get a lot richer. And they did. And they used the riches that they amassed from this new form of antitrust to make it sturdier. So among the other things that they did, they endowed a lot of chairs at universities. They started journals and think tanks. One of the most effective things they did was they started these seminars for federal judges called the MANN seminars, M-A-N-N-E. And these were fully funded federal junkets for judges where you could go to Florida for a couple of weeks and stay in a luxury resort and do continuing education about antitrust. And while you were there, you would go to all these lectures about how antitrust should only be enforced according to consumer welfare, and how any harmful dominance standard was just a hopeless muddle, and how monopolies were efficient. 40% of federal judges sitting on the bench today attended a MANN seminar. And when you look at their decisions on antitrust before and after the MANN seminar, they're radically transformed. So consumer harm is nearly impossible to prove, and that meant that the kinds of activities that we used to prohibit were now allowed. So a company could merge with its major competitors. It could acquire its nascent competitors. It could create a vertical monopoly. That's where you own different parts of the supply chain all under one roof. And the story of that led to the world that we're in today. That led to the kind of tech monopolies that we're in today. Now, that's not what you'll hear when people talk about tech monopolies. Usually if you're talking about tech monopolies and there's an economist in the room or someone who's heard something from an economist, they say, oh, the reason that we got tech monopolies is because of something called network effects. Network effects are real, right? Network effects are when a service gets better, the more people use it. So like the more sellers there are on eBay, the more reason there is to go and search there to buy stuff. And the more buyers there are on eBay, the more reason there is to go be a seller there. You might join Facebook because all your friends are there. And once you've joined Facebook, all of your friends who aren't on Facebook yet are now tempted to join to come and hang out with you. Those are network effects, right? When there's no iOS apps, there's no reason to buy an iPhone. But once people own iPhones, that's a reason to make iOS apps. And once there's a lot of iOS apps, that's another reason to buy an iPhone. So network effects are real, but they're not the whole story. When you look closely at how the tech companies grew, you don't just see network effects. What you see are just violations of antitrust law, a form of Moneyball, where companies that have access to the capital markets because their investors are willing to fund them at a loss so that they can create monopolies and extract high amounts of profit from the rest of us, those companies go out and they buy all their competition. So think about Google, right? Google is a company that's very successful, one of the largest companies in the history of the world. And Google is a company that's only made 1.5 successful products. They made a really, really good search engine and a pretty good Hotmail clone, 1.5. Everything else they made in-house has not been successful, with the exception of Google Photos. But Google Photos is not successful because it runs on its own. Google Photos is successful because it runs on a product that they bought from someone else, Android. In fact, every successful product they have, except for Search and Hotmail, is a product they bought from someone else. Their whole ad tech stack, their mobile stack, YouTube, all of their successful products were bought by someone else. And those purchases of other companies, most of them would not have been permitted prior to the Bork and Reagan years. And those are the years that coincide with the dawn of the PC. You know, the Apple II Plus, the first commercially successful home computer, that computer that I sat around playing on when I was a kid, dialing my modem up and talking to BBSs, that hit the market the same year Ronald Reagan hit the campaign trail. Now, network effects are real, but with tech, network effects are different, right? It's true that if you're a grocery store that has branches on every corner, everyone's going to want to sell their products on your shelves. And once everyone's selling products on your shelves, you can go on every corner, right? That's true. But it's not quite the same with tech, because tech has something called interoperability. That's where you can plug one thing into another. So, as you know, if you're a software person, if you're a tech person, computers are universal. They can run all the programs. We don't know how to make a computer that can run most of the programs we can express in symbolic logic. And, where's the pity? If only we could do things like build a printer that could only run software to drive the printer hardware and not also be a place that you can hide malware and use as a point of entry into someone's network. That would be amazing. We don't know how to do that. We only know how to make the computers that run all the programs, the Turing complete computers. And the good side of that is that means that you can always plug something into something else. You can always wrap an existing technology in a compatibility layer. You can always scrape things. You can always add something as an API. You can always take a program that thinks it's getting input from a user and actually feed it input from another program, and then take its output and feed it back into that program, and so on. We can always plug something new into something old. And what that interoperability does is it lowers switching costs. Because switching costs are why companies stay big. Network effects are how they get big, but switching costs are how they stay big. Like, you join Facebook because your friends are there. That's a network effect. But you stay on Facebook even though it's making you miserable, because if you leave, you have to. And there's no reason that has to be the case, right? Facebook could just offer an API that allows third parties to plug into Facebook. So you could quit Facebook and you could talk to your friends over Twitter or Diaspora or an email gateway or, MySpace, right? Those are all possibilities. And, Facebook doesn't want to offer the API. You can make your own API, or if you can't, you could ask someone else to, or hope someone else to, or you could invest in someone else who wants to do it. They could write a bot that goes and scrapes all the waiting Facebook messages that are waiting for you in your Facebook queue and puts them in an inbox somewhere else, and then lets you read them and reply to the ones that matter to you and like them and do whatever it is you might do on Facebook, and then goes back and pretends to be you and likes things and reads things and checks things and forwards them, just as you would if you were sitting there at your console. That second kind of interoperability, where you make your own API without the cooperation of a dominant platform against their wills, that's a thing we call competitive compatibility. We used to call it adversarial interoperability, but it's just too much of a mouthful. And compatibility, rather competitive compatibility, it boils down to this great little phrase, ComCom, which is a lot of fun to say. And ComCom, it's been with us for as long as we've had computers. It's part of the reason things were so dynamic. I mean, that's making Phoenix ROMs and then letting Gateway and Dell make hardware rather, that can run software that was intended for the IBM PC. But it's shot through the entire history of technology. Like around the year 2000, 2001, the Mac was in a lot of trouble. I was a CIO back then. I managed these heterogeneous networks that had Macs and PCs. And I have to tell you, like, the Macs were on the ropes. And it wasn't because they weren't good computers. It was because they didn't have a full-featured version of Microsoft Office. And so if you were like the designer in an office full of people who use Windows machines, and you used a Mac running, Quark and Photoshop and so on, and someone sent you a Word file, chances are you couldn't read it with Word for the Mac. And if you could read it and you made some changes and saved it, chances are the people who you work with couldn't read it. In fact, maybe you couldn't ever read it again. It was one of the worst pieces of software I'd ever used. It got to the point where I was actually, in some cases, putting a second computer on the desk of those designers so that they could have a way to communicate with the rest of the office. And in other cases, we were just migrating designers off of Windows, off of the Mac rather, and onto Windows, because they just had this powerful network effect. There were all these Word and Excel files, PowerPoint files that were tied to the Microsoft Windows platform. So every time someone made an Office file, it made Windows more valuable. And every time someone joined the Windows world, there was another person who could read and write those Office files. So they had this network effect going for them. And then they had this switching cost, this very high switching cost, that if you left, you'd have to leave behind everyone who'd been sucked in by the network effect. So Steve Jobs did something incredibly clever. I'm not the world's greatest Steve Jobs fan here, but you got to give him props, because what he did, he didn't go to Bill Gates on one knee and say, Bill, please get some engineers to make a decent version of Office for the Mac. Instead, he just got some Apple engineers to reverse engineer those file formats, Word, Excel, PowerPoint, and then they made a thing called the iWork suite, Pages, Numbers, and Keynote, that read and wrote all of those Microsoft Office files basically perfectly. So that was ComCom. That was competitive compatibility. And what happened immediately after that? Microsoft stopped trying to maintain non-interoperable versions of its Office suite. Instead, they standardized it, because they were like, we spend so many engineer hours making these non-interoperable nonsense file formats that are deliberately obfuscated and non-functional. It costs us a lot of engineering hours, and it makes our customers crazy. Now that it's not giving us the advantage of high switching costs, let's just standardize. And it's not just Apple that did it. Every tech company has a story like that in its past. When Mark Zuckerberg started Facebook, he had a problem, which was that everybody who wanted to use social media already had an account on another platform called MySpace. And MySpace, it's a joke now, but it was owned by this rapacious billionaire named Rupert Murdoch, notoriously one of the most ruthless people that ever lived. And he wasn't going to let his customers go without a fight. And so what Mark Zuckerberg did, what Facebook did, was they made a bot like the one that I described, except it wasn't to help you get off of Facebook. It was to help you get onto Facebook. Facebook was a better service than MySpace. They didn't allow anyone except for your friends to see your messages. They were the more private platform. I don't know if you remember this. This is how Facebook pitched itself for the first 10 years, the privacy alternative to Google and MySpace. And the problem was that none of your friends were on Facebook yet. And so you could quit and go hang out on Facebook with its much better user interface and better privacy protections, and there was no one you wanted to talk to there. So rather than demanding that you and all your friends plan international everybody quits MySpace and joins Facebook Day next Wednesday, 3 p.m., he just gave you a bot. You gave it your login credentials for MySpace. It would go to MySpace, pretend to be you, get your waiting MySpace messages, put them in your Facebook inbox, you could reply to them there, push them back out to MySpace, and they would have a footer that said, I sent this from MySpace. Why are you still on Facebook? So ComCom was really important to the growth of these tech giants. But these tech giants have now figured out how to eliminate ComCom, to make ComCom almost impossible. They have expanded the doctrine of software patents and software copyrights. They've expanded a particular kind of software copyright, which is anti-circumvention. That's the rule that says that if you have to break DRM, it's a crime. felony punishable by a 5-year prison sentence and a $500,000 fine under Section 1201 of the Digital Millennium Copyright Act. And they figured out that this means that if you just take any piece of technology that you don't want anyone to do COM to, that you don't want reverse engineered, and you just wrap like a 1 molecule thick layer of DRM around, it doesn't matter if it works or not, that anyone who unwraps the DRM from it can go to jail. So like Apple could reverse engineer the Microsoft Office formats, but if you tried to do that to the iTunes formats, because they embody some DRM, you could face a prison sentence, a 5-year prison sentence for a first offense. They've also advanced theories that make terms of service enforceable. Thankfully, the Supreme Court has narrowed that a little this year with a case called Van Buren, but Facebook has gone after people for violating its terms of service and said, you're committing a felony by violating our terms of service under an old law called the Computer Fraud and Abuse Act. And then, one of the things that these tech monopolists were able to do, because they had so much money, was they were able to try to buy very expensive new interpretations of existing laws. So Oracle spent hundreds of millions, maybe even billions of dollars, trying to convince courts to allow it to apply copyright to APIs, so that doing the very fundamental interoperability step, right, making command compatible new software, would be a crime if you didn't get permission from the company you were doing it to. Now, all of these different kinds of ways of blocking COM, of blocking adversarial interoperability, patents, copyright, anti-circumvention, terms of service, these exotic rights like API copyrights, they all are different, but they all have a name that people use to describe them in business speak. They call them IP, or intellectual property. And, the free culture movement, the open source software and the free software movement, they don't like the term IP. They say, oh, well, it's, imprecise. Trademark is not like copyright. Copyright's not like patents. And besides, none of this stuff is property. It's their, regulatory monopolies at best. That's what we used to call copyright in America. Before the term IP, we called it the author's monopoly. And of course, people who like IP don't like having it called the monopoly. It's much nicer to go to Congress and say, my property is being stolen, can you help me? Than my monopoly isn't expansive enough, can you make it bigger? But, I've come to realize for about a year now that what we used to think of as this incoherent category of IP that just meant whatever anyone wants it to mean actually has a super crisp and precise meaning when applied to business contexts. When a business person says that they want to get some IP, or that they're buying and selling IP, or that you violated their IP rights, what they're talking about is any right that allows them to reach outside their company's borders, to exert control over customers, critics, and competitors. So if you've got IP, and a security researcher reverse engineers your product and discovers that it has gaping security vulnerabilities and wants to warn your customers, you can threaten them for having violated your terms of service or your non-disclosure agreement, or for having reverse engineered and bypassed some DRM and therefore having violated anti-circumvention law. You might even bring a patent suit against them. All of those things, all of those IP rights are a way to silence your critics. Here's a really crude example of how it can work. You've heard of Goldman Sachs, this giant finance vampire that was, behind every major financial scandal for the last 30 years. Goldman Sachs released a free font called Goldman Sans. It's their logo font, and it's free. So it's got a terms of service with it, but the terms of service aren't to make you not copy it. They want you to copy it. It's free. The terms of service are there because when you download it, you agree to a non-disparagement clause, which is to say that you promise not to criticize Goldman Sachs using Goldman Sans. They don't need IP to protect their copyright. They need IP to stuff a gag in their critics' mouths, stop their critics from speaking. And likewise, if you're Facebook and you've got your product that's designed to work a certain way, according to your commercial priorities, according to your shareholders' priorities, you don't want a competitor coming along and changing how it works. So there's a British technologist who made a plugin for Facebook, a Chrome plugin, called Unfollow Everything. And what it does is it goes through and it unfollows all the pages, groups, and individuals that you are currently following. Now, your friends are still your friends. You're just not following them anymore. And it means you no longer have a news feed. And what you can do is you can go back and you can either add people and groups to that news feed again, or you can just go like, I wonder what Tony's up to today. And you can look up Tony, and because he's your friend, you can see what he's posted to his wall. But you don't get the infinite scroll. It's a lot easier to leave. And what this developer found was that not only was it good for him, but for his users, it let them use Facebook in a way that felt better for them. They used it less and they enjoyed it more. So what did Facebook do? They asked Chrome to remove it from the Chrome store, and they sent him a legal threat saying he'd violated their terms of service, and they would sue him if he didn't retract it. And if he ever made anything else that interacted with Facebook in any way, they would sue him for having violated the terms of service that he agreed to. It's not the only time Facebook's done that, and it's not the only time, and Facebook's not the only company that has done that. But this is a way that they can decide how their competitors work, right? They get to decide who can change the way that their customers use Facebook. And then they also get to control their customers, but so do all kinds of other IPs. So like if you have a printer and you want to put third-party ink in it, you got to be really careful, because companies like HP and Epson and Brother have started shipping fake security updates to your printer. And when you install them, it patches your printer so that it's better able to distinguish third-party ink from their OEM ink. And that OEM ink, they charge more for it than you would pay for vintage champagne. And what they say is that reverse engineering those measures that block third-party ink is bypassing DRM, it's violating patents, it's violating terms of service. What they're really doing is they're controlling you, so that you have to buy the ink that makes them the most money instead of the ink that you would prefer to use. It's as if Nike could force you to buy shoelaces that were specifically designed for Nike shoes and that cost 1,000% more than the generic shoelaces they sell in your local pharmacy. And so that's really what IP has come to mean: the ability to control your critics, your competitors, and your customers. And this IP monopoly, right, this author's monopoly, it's different from a market power monopoly. Market power monopolies are theoretically illegal. And if you are too obnoxious in what you do to defend your market power monopoly, right, like if you try to raise prices and then collude with other entities to keep the prices high. So like if you're the big 6 publishers and you get together with Apple to agree that the price of an ebook will be $10, and then you all agree you won't sell ebooks to Amazon until they agree that it's $10, which is a thing that actually happened. That's the one thing that antitrust will actually defend against, because they say, well, it's inefficient if you're making the prices high. And so if you can then combine that somehow with these authors' monopolies, with this IP, you escape any possibility of being enforced against by antitrust enforcers or any other kind of enforcer. If you use your patent to exclude other market entrants, you are not being a monopolist, you're being a patent holder. If you use your rights over DRM to stop people from making interoperable iTunes players or Netflix players, you are not being a monopolist, you are protecting your copyrights. And so not only do you get a monopoly that you can defend freely, but in fact, because it's a copyright, you get something that the government will defend on your behalf, that they will let you use the criminal courts to go after people who frustrate your shareholders' ambitions. And so this is a new kind of monopoly, right? This is a monopoly that fuses market power with IP and creates an even sturdier form of monopoly than we've ever seen before. A monopoly that is not only legal and not only untouchable by the law, but that the law will actually help you defend. Now, I started this by saying that the early internet boosters were not blind to the perils of technology, but maybe they were a little. I mean, after all, during those dynamic years before the web turned into 5 giant websites filled with screenshots of text of the other 4, there was so much money sloshing around. And if you could convince yourself that technology was an unchecked force for good, maybe you could get some of that money. The myth of 2 hackers in a garage who could topple billion-dollar giants and become billionaires themselves fired a lot of techies' imaginations and sidelined a lot of their consciousnesses. But those days are behind us. You know, these days, the big tech platforms have billions of dollars in profit, double-digit year-on-year growth, and no investor will invest in a startup that competes with them. They call the lines of business that the big tech platforms are in and the lines of business that they're adjacent to, they call them the kill zone, because they know that big tech can just come in and either use predatory pricing where they give something away that you're charging for, or lock in suppliers or lock in users, and they can just force you out of the market. And so no one wants to invest in those things. And what that means is that your dream of growing up to be a hacker who quits your job at a big, lumbering, dumb technology giant and starts a nimble, new kind of tech firm in your garage that 2 years later destroys them, that dream has been replaced by a much narrower dream. Like maybe you can do a tiny little startup that becomes an acqui-hire, and they hire you for Facebook, and you get some options, and you get free massages on Wednesdays and kombucha on tap in the school in the campus cafeterias. So this is not the kind of dream that techies used to use to fool themselves into thinking that they could do well and do good. These days, techies are becoming increasingly disillusioned with this proposition, and that means that they're being a lot more honest with themselves about what their work means. And the companies themselves no longer have to worry about losing customers to their competitors because of their lock-in, because of their high switching costs. And they've pivoted from trying to figure out how to make people happy to figuring out how to abuse us for profit while locking us in and manipulating us. And, you know, if you do get into a position where a tech platform decides that you are being too obnoxious and trying to figure out how to exercise your self-determination, trying to figure out how to use their platform in your way and not their way, well, they can always just take away your right to use the platform altogether. So when you lose your Facebook account, you lose your Oculus developer account, and you lose access to the WhatsApp groups where your family hangs out, and you can no longer log into any of those services that you log into with Facebook. If you lose your Apple account, you lose all the apps you've bought, you lose all the media you've bought, maybe your home automation system shuts down. You might lose all of your email archives with Apple Mail. You might lose all your photos with Apple Photos. You might lose all of your cloud files, including those files that your accountant gave you that you need to survive the audit you're going through next week. If you lose your Amazon account, same. You lose your Google account, same. So these companies have created a situation where everything, our media, our email archives, our access to our families, everything is locked into their silo. And the cost of switching is losing all of that stuff. And even the cost of just making them angry is potentially losing all that stuff with no recourse, no access to a judge, no access to a jury, no access to justice. So all of that sounds like bad news, but there's some good news too, because what's happening in tech is not just happening in tech, it's happening everywhere. The theories of Robert Bork that demanded forbearance for monopoly, they spread out to every industry, and they spread out all over the world. The Borkian theories of consumer welfare became the dominant consumer antitrust theories in Australia and in Europe and in parts of Asia and in the United Kingdom. And so we see monopolies everywhere dominating every industry, whether it's cheerleading uniforms or eyeglasses or beer or tobacco or spirits or shipping or finance. Every sector is down to between 5 and 1 companies. You know, think about professional wrestling. There used to be dozens of professional wrestling leagues. Trumpy billionaire named Vince McMahon bought out or forced out all of his competitors. Once he was the sole remaining large wrestling league in the world, he reclassified all of his wrestlers as contractors, took away their health insurance, and that's why the wrestlers you grew up watching are now on GoFundMe, begging for pennies so they can die with dignity of their work-related illnesses and injuries on GoFundMe. Well, that sounds bad, but I'll tell you why it's good. It's good because it means that there are a bunch of people who are fighting the same fight that we're fighting, and they don't know it. They just don't understand that the same issues that bother them, you know, if you're a screenwriter who went on strike for 3 years because there's only 4 talent agencies left in Hollywood, and they'd all decided that they would take bribes from studios in exchange for less money for their writers and more money for them, which is a thing that literally just finished. You don't understand that you're on the same side of parents who are angry that cheerleader uniforms went up 1,000% because there's only one company that makes those. Or people who wear glasses who are pissed off that one company, a French-Italian conglomerate called EssilorLuxottica, owns every single eyewear brand you've ever heard of, from Versace to Oliver Peoples to Bausch & Lomb. They own every eyewear store you go to. They own Target Optical and Sears Optical, and they own Sunglass Hut, and they own Specsavers and Lens Crafters. All of those are one company. And they also own the lab that makes more than 50% of the world's optical lenses. And they own the world's largest eyewear insurer, IMED. And they've raised prices 1,000% over the last decade too. So all of us are angry about the same thing. We just don't know it. And what that means is there is an opportunity to form a coalition. My friend James Boyle, is a copyright scholar, teaches at Duke University. He has this wonderful analysis of how political movements come together based on the founding of the phrase ecology. He says that before the word ecology was coined and popularized, there were a lot of people who cared about what we today think about as ecological issues. I might care about owls, and you might care about the ozone layer, but it wasn't clear that we were on the same side. After all, charismatic nocturnal avians don't, on the face of it, have anything to do with the gaseous composition of the upper atmosphere. But once the term ecology was coined, it suddenly meant that there was a reason for all of us to fight each other's corner. I mean, maybe I only abstractly care about the ozone layer and really care about owls, but we're both ecologists, so I'm going to come out to your demonstration, you'll come out to mine, and we'll vote as a block, and we'll protest policies together, and we'll work together. We'll form a coalition, and that coalition is today the result of all of those different 1,000 issues becoming a single movement. And that's where we're at now. 40 years after antitrust was gut shot, it's starting to come back to life. The new FTC chair, Lena Khan, is a fire-breathing trust buster. So is the person running antitrust over at the DOJ, Cantor, and so is Tim Wu in the White House running antitrust for tech there. All of a sudden, people all over the world are starting to talk about monopolies in new ways and identify them as a new kind of problem. There's 6 antitrust bills in Congress and I believe 2 in the Senate right now. So we are really at this inflection point, with antitrust action being contemplated in India, Australia, the United Kingdom, and the European Union. So that's my message to you, is that although all of this stuff might seem hopeless, that you have allies that you haven't ever suspected were out there, and that the situation that we're in is not natural. It's the result of people making choices that created this circumstance. And it doesn't have to be this way. Tech didn't turn into a monoculture because it matured. It turned into a monoculture because its diversity was stolen from us in order to enrich a small coterie of super rich people whose names and home addresses are a matter of public record. We don't have to let them continue to run our world. We can do something about it. So I work with the Electronic Frontier Foundation, EFF.org. We're a charitable nonprofit that works on this stuff. And we have a network nationwide in the United States called the Electronic Frontiers Alliance of local organizations that work on this stuff at the local level. And if you want to get involved, you can look up your local Electronic Frontier Alliance organization. You can also think about donating to the Electronic Frontier Foundation to support our work. And you can get involved in other kinds of anti-monopoly work, because wherever you are, there are people who are pursuing the anti-monopoly cause. Well, I've talked for a long time here, especially for a pre-recorded video, so I'm going to leave it at that. I really appreciate your patience, and I'm really honored to have had the chance to speak to you today. And I hope I can come in person someday and talk to you again. Thank you.
Well, thank you, Corey, so very, very much. And as we wind down the SeaGL streams, once again, we'd love your thoughts about how we did, where to improve. Please submit them at seagull.org/feedback. Thank you, JMP Chat and Amazon Web Services, the SeaGL 2021 Platinum sponsors. Everyone should be sure to stick around for tea sandwiches with Molly and Shree and trivia with Remy and Alana in the SeaGL social channel. We also wanted to mention that the SeaGL community will be chatting year-round on Matrix. And please, consider joining the volunteer SeaGL staff, submitting a session, whether it's your first or 50th, sponsoring or asking your employer to sponsor a future SeaGL, and telling your friends, family, and broader community about this amazing and wonderful event. Thank you all for a fantastic SeaGL 2021. If not before, see you all in 2022 on November 4th and 5th for the 10th SeaGL. Have a good evening. Talk to you soon.